Okay. Evening, everybody. So we just walked through the paper quickly. We have all our structures here. Look, the first thing I like to do here is when I see this, I just want to check. I want to check what I know about each structure very fast. What do I know about this? This is a haloalkane. All right? It's a haloalkane. What is this? It's an alkyne. What is this? It's also an alkyne. Oh, it's an alkene. Sorry, alkene. Oh, even this one. I'm tired, guys. It's an alkene as well. Thank you for the correction. Means you guys are up to date and up to speed with what you're doing. Butane 2 on. All right. This one is what? An aldehyde. And why is it an aldehyde? It has a CHO. And people normally forget this CHO. It is called the formyl group. Butane 2 on is your ketone. And this is your alkyne. And what is this? This is your alkane. And this is your carboxylic what? Acid. And because it has what you call a carboxyl group. Okay. So just quickly looking at that, I think we'll be able to answer all kinds of questions here. Which one is a ketone? I think it's already done. E has the general formula CnH2n minus 2. Minus 2 is an alkyne. And that is be what? F. An isomer of 2-methyl-but-2-ene. You want to give me an answer to that? It's very simple. Once you are looking for isomer, how many carbon atoms is meth? 1. How many carbon atoms here? 4. So I'm looking for something with what? 5. I hope that makes sense. Isomers are organic compound with the same molecular formula but different structural. So that's what I just do. Methyl, butane, 1 plus 4 gives me what? 5. And I'm looking for an ene that has a 5. Make sense? Has the same molecular formula as ethyl. Now, same molecular formula. This examiner is simply asking for isomers. All right? And isomer, if I look at functional isomer of this, that's an ester, right? It's a carboxylic what? Acid. You don't even have to do so much. Ethyl, 2. Ethanoate, 2. Which gives me what? 4 carbons. I'm looking for a carboxylic acid with 4 carbons. There's only one carboxylic acid here, which is what? H. We're done. So esters and carboxylic acids are functional isomers. I think if you always check, I'll tell you for a function, we need what? A cake. And then we smile because of the cake. Carboxylic acid and esters, aldehyde and ketones. So when I see an aldehyde, I know the functional isomer is a ketone. When I see a carboxylic acid, the functional isomer is therefore an ester. We good? 4 marks, everyone getting that. Write down the IUPAC name of A. Yes, I love this one. IUPAC name of A. If you check, our longest chain would be what? 1, 2, 3, 4, 5, 6. But that's not just the only way to count. You've got to count right? 1, 2, 3, 4, 5. It is still 6. Whichever way you go, it will be 6. What I like to do is once I get my parent chain, I put a block. So we're fine with that being 6. Whatever is not in is a side chain. It's quite easy that way. So and sides need to be numbered. The question is, where do we start from here? Please, this is a haloalkane, and examiners are very cheeky on this one. No one has preeminence over the other. What do I mean? The methyl and the halogen, no one is given preference. What determines your numbering is it must be closest to the end. I don't know if what I'm saying makes sense. Let me try something. Let's make it bigger.
So double bonds have preference over the side chains, right?
Yes, double bond would then have a lot of preference.
Double bonds between carbon atoms or double bonds in general?
No, we're talking about double bonds. Once I give a double bond that is not in between carbon atoms, then I'm talking about a different compound completely.
It's like a ketone.
A ketone, then the double bond is just the one that takes the preference.
Double bonds in general.
Yeah,
And triple bonds?
same thing. And that's only in alkynes. Right? So check this. If we were to label this now, all right, we said this is what? 6. But check this guy. If I start from here, this guy is on carbon number what? 2. And this guy is also on carbon number 2. If I start from here, there's a methyl group on carbon number 2, which actually cancels this preference. Because it's 2-2. Looking at just that one only. But come down here. If I start from this is on carbon number 2, and this is on carbon number 3. We've got to look at the ones that are closest. A simple way. What is 2 plus 2? 4. What is 2 plus 3? 5. You must go for 4. All right? So please, look, I want, if this was not there, this is not there. I have both on carbon 2. No one takes preference. Now I will then go for alphabetical order. Bromine before methyl. Then I'll start by numbering from this direction. Right? Okay, this one is not there. Let's take it gradually. Change the structure in one. This guy is not there. I have bromine on carbon 2 numbering from here. I have methyl. They look as if they are of the same potential. No one takes preference. But I'm then going to go for what? Alphabetical order. Bromine comes before what? Methyl. So I'll come this way. Bonga? This is not C. What is this compound? It's methyl. M. This is methyl, not C, not letter. This is bromine. Bromine comes before methyl. Right? Alphabetically, what letter is this? What letter is this? Alphabetically, which one comes first? Done. No, you were saying C. C is a compound, not a name. Right? So bromine, so they are both 2s, right? From both sides. But then I look at what? Alphabetical order. Now, we are changing the whole thing. Please follow. I'm doing this all kinds of structure here. If I have this, no. Let me cancel this one. If I have this one, will it change the numbering? Please, I wanted to check. I'm going to start by looking at my bromine again, right? If I number from this side, bromine is on carbon number what? 2. This guy would be on carbon number 1, 2, 3, 4. Right? So I'll be dealing with 2 and what? 4. Make sense? If I number from this side, what will I be dealing with? 1, 2. 1, 2, 3. I'm going to number from this side. These 2 and these 2 nullify each other because they are both on carbon 2 from the other side. Now, the neutral one, where is it closest to? Closest to the right. Your side chains must be closest to the end of the structure. So I'll be numbering from this side now. This becomes 2-methyl, and then we continue.
So when numbering the alkanes, you count the alkane as one of the side chains.
It's a side chain.
So what? Okay.
As long as it's not in your parent chain, all of these are what? Side chains. So if I have a structure like this, I'll have to start naming from here. IUPAC rule. So we all have the same name. Okay? Let's cancel this. Please don't get confused. Just follow the rule. If I have this, which side will I number from? I just I'm going to number from there. There's no need to do magic here. Because this and this still cancel each other, right? 2, 2. Let's look at the neutral one. It's from here. It will be on carbon number 2. But from here, it will be on 1, 2, 3, 4, 5. We don't go that far. It's always closest. Now, if we have all together, what are we going to have? Again, this and this, they have the same effect. Carbon 2 from here, carbon 2 from there. Can we consider this one now? Which one is closest to the end? From the left-hand side. So this is carbon 1, carbon 2, carbon 3, right? 4, 5, and 6. I have a methyl on which carbon? I have a methyl on carbon 2. I have a methyl on carbon 4. And I have what? A methyl on carbon 5. Now, I hope you got what I explained. Especially when it comes to alkane, no one takes preference. But if I go to other compounds like alcohol, alcohol must take preference. If I go to a ketone, the carbonyl group must take what? Preference. If I go to, which one again? This numbering. Aldehyde. That one is always on carbon number 1. Carboxylic acid. All other ones, the functional groups take what? Preference. Here, because it's an alkane, it's derived from an alkane. The bromine doesn't take preference over the methyl group. And the methyl will not take preference over the what? Bromine. We look at the one closest to the end. And again, like in this case, if I start from here, this is on carbon 2. If I start from here, it's on carbon 2. If this one was not there, we use alphabetical what? Order. But now, if this one is there, these ones are enough, they've cancelled each other, if I want to explain that way. Then we look at the neutral ones and use that one to do what? To decide. This is so that everyone has the same ruling or naming system. That's why we call it the IUPAC naming system. Now, what's the name of this compound? Now, I hope you're fine. Now, what's the name of this compound going to be? Again, we have to arrange what? Alphabetically. This is what? Bromine. So which one comes first? Bromine. So we start from there. 2 dash bromo dash. Now, all of these are the same. So what do we have? 2, 4, 5. Tri, methyl. Is it hex? Hexane. And you might be losing 2, depending on the structure. If you get your numbering wrong, you might be losing 2. If it's 2 similar side chains, dimethyl. They don't have to be on the same. For example, if I remove this one, what will it be? 4, 5 di. As long as methyl is the same methyl, we bring in di. All right? If I cancel the 5, then it will be 2, 4. Dimethyl. Are we okay, guys? All right. It will come again in multiple choice. I know these things. And examiners like bromo and... So if you find any structure that you see, I'll also look for. Please send on the group. Let's name together. The what? It will change the it will change the naming. All right. In this case, it was ethyl. B still comes before E, so we're still fine.
So it doesn't change the way.
No. It just changes your arrangement here. So if I had ethyl here, I would definitely need to write before methyl. All right. Are we okay, everybody? Between a number and a letter, a comma. Between a letter and a number, hyphen. If you lose that, you lose 1 mark.
Is it asking if it has more than 1 grammar?
Then it becomes 1,2 dibromo. Same rule. If it's bromine, then it becomes what? Di. And you give the address.
So halogens can go on the terminal active.
Sorry?
Only halogens can basically go on the terminal active of number 1.
Yeah, you cannot put a methyl on.
Yeah.
It's a chain already if you put a methyl there. I think I was doing this when I was talking about isomers of. You remember that they were doing isomers of butane? Here we had to draw so many of them. Once you put it at the end, it's a chain. All right. I think we'll look at a few more structures. Structural formula of F. I don't think that's difficult. 4,4-dimethyl pent-2-ene. We start from the parent chain. 4,4-dimethyl pent-2-ene. Let's draw quickly. We're not taking.
An example of how the functional group took a preference over the side chains.
What?
The numbering. The functional group took preference over the side chains.
Yes, because the 2.
It's 2. So the functional group is sitting on carbon number 2. All right. You see that the methyl is on what? 4. So we give. It's very simple. If I come to your house right now, let's forget about being good-hearted. Come to your house right now, and there's just one plate of food. Your dad is going to give you first. You are a member of the house. I'm a side chain. So so I know, but I'm just looking at, but it makes sense. It makes sense, right? To say, okay, look, my. All right. Fahima, that's extreme now. Okay, a girlfriend on a side chick. You've got to give your girlfriend first. All right. This is going in a very different. It's going in a very different direction now. Okay.
I say last 50 rand in your pocket. Who are you going to buy those for?
Okay, you're going to buy for your girlfriend.
Yeah. Okay, so because my girlfriend is part of the house, side chick can leave. All right.
Which wife are you going to buy for?
Okay. Can we not leave? Can we leave 2 wives? 4, split the roses. I'll draw the rose on the paper and give both of them. Make a photocopy. All right. 4,4-dimethyl pent-2-ine. All right. Now you will see that here, this is the owner of the compound, ine. That is what takes what? Preference. 4,4-dimethyl pent-2. Let's quickly draw that. 4,4 di. Oh, that's wrong. 4,4 dimethyl pent. All right, where do we start from? Start from the parent. 1. And please don't try to be funny. I see learners. Instead of just drawing 5 chains, Elena is trying to show that they know chemistry and start doing. Oh, for what? Yeah. For what? Just do 5 straight. Don't.
If it's 8 or 7, then that's still understandable. Then
No, even if it's 8, I'll draw it. There's enough space. Why should I?
4 there.
Leave me. Please, guys, you even make the marker angry. That, this child now, because the marker is trying to check what you are drawing. Paint, just make it simple. Paint. Carbon number 1, carbon number 2. Please, if I put it here, it's wrong. It's carbon 1. Carbon number 2. Now, I'm done. But now I have... What? Oh, triple bond. Okay, easy. All right. Okay. No, this is now, if it's from the right-hand side, this is now 3. Yeah, it's fine. There's no rule that says you must number from the left. Or rule just, no, there's no rule. All right. Pent-2-ine, right? What do I have? Methyl group on number 4. 1, 2, 3, and then 4. Is that fine? So what do we have? Please don't do this. All right. Okay. We don't do that, right? And don't be lazy. Please, guys, trust me. When you do this, before you leave the question, count the number. Sometimes we just get, it's carbon, and we do that. It's even as a teacher, I do it. All right. So please, once you are done drawing, count to see. It must always be what? 4. All right.
You mistakenly draw a line and you just scratch it out and you find once you redo the whole thing.
If the line is cleaned, no, you cannot use Tipex. Okay. Let's say someone did that, right? And then you realize later, and you cannot Tipex. Like I can clean. Please. No, actually, you should draw in pencil. Pencil, just for something like this, if you make a mistake. But there's no rule that says you must draw in pen. But should you have drawn in pen? Listen, don't make life difficult. And please, don't cancel with you are a civilized person and say, okay, now let me just do that. And I don't want you to. Please. It's your paper. Please. Don't say, oh no, it's going to look dirty. It's going to. If you can use a scissors to cut that thing out. Please. Because now, in the exam, let me tell you what happens when we mark. Somebody now does that. We don't know whether it's by me. We start taking your script from marker to marker. Do you think that child cancelled? Or it's a mistake? Once you start giving examiners issue to say, is it yet? Please. Please. Check. No one can doubt. Are you going to say, did this child cancel? Yes. That's a full-time cancellation. So, because I'm telling you the things we go through when we mark. We take, you first show your neighbor. Do you think he cancelled? That one said, no. Then when you are about to mark, you say, no, wait, yes. At the end of the day, we might, but again, if it's moderated and whatnot, then say, no, why did you give? Now it's you being a bad marker. Your reputation is also. Which one? There. No, that's just the writing. Yeah, Bibi, you wrote N. Your age was like this. And I think I have a witness. Yeah, it was. Okay. Okay, all right. But please, I know that you wrote an H in practice, but in an exam, let's write it clear. Like I said, don't give an examiner any room to doubt what you've written. Because you're not there to explain that, but say it looks like an H. No, you don't even know who's marking. Okay, let me say things. Compound D. Okay, I think we're done with D. D, aldehyde, we're done. All right? Aldehyde, we're done. All right, what else? Name it. Oh, I actually answered. Its functional group is what? A 4-mile. And if they ask me to draw, it's that, right? The H must be there. Is that okay? That's the functional group. Are we okay? You remember the 4-mile, right? If it's for a ketone, okay, let me write the functional for a ketone. A functional group is what? C double bond O, which is what? A carbonyl. Please take notes. There's a carboxyl. There's a carbonyl. Is that okay? A carbonyl is the CO. A carboxyl is the COOH because of the word carboxylic. And if it is alcohol, it is what? Hydroxyl. Make sense? Please don't forget these names. Name of the functional what? Groups. Hydroxyl OH, carbonyl CO, 4-mile CHO, carboxylic COOH. Those are the main ones that we have in terms of the names.
The carboxyl group be the terminal one also.
Can the?
Carboxyl group, the double bonded O in 2 terms.
Then it becomes an. Then it becomes an aldehyde straight.
So it has to be like.
It has to be in the middle. Idris, question? Where's COH? COH doesn't like it. COH is now alcohol. Let me make that very clear. Let's look at the difference between those. So, if I have anything that has OH. This is now what? An alcohol. But if I have CHO, it is an aldehyde. So let's take note of that arrangement. HO, aldehyde. OH, alcohol. Yes.
You won't call it alcohol.
No, you cannot call an alcohol aldehyde. They are completely different. The structure for this one is that. The structure for this one is this. And this is always on carbon number 1. Aldehyde. Carbon number 1.
It's aldehyde, so they won't be able to put the O before the H.
No, it's an alcohol. So don't let's create other compounds. Once you have O before H.
No, but then we can always check with the general formula to be sure.
No, the general formula will be the same, most likely. Okay, no, it will be 1 carbon less because of this. But please just know that OH, they will never write alcohol as HO. Done. Okay? It is always what? OH, hydroxyl. Is that fine? And aldehyde cannot be written as what? OH. It is what? CHO. And that O, Fahima, you were asking if I can put, let's check this. Look at this, guys. What is this? What is this? That's a ketone. Why? This guy is sandwiched in the middle. Once I bring this here, check. I'm moving it, right? And they are not positional isomers. They are, listen, what is the function? Let me write the functional group. Okay, let me circle it. This is the functional group, right? Now, if I move it there, I'm going to have this, right? But there's a hydrogen. That's no longer the same. This is aldehyde. CHO, aldehyde. So these are functional isomers. So don't go and say this is positional isomers because the double bond is on carbon 2 and it's on carbon 1 here. No. They are 2 complete different functional groups.
In the functional group, it's like a O bonded to a C.
This is carbonyl. It's just C on the O there. And you have CC. But this one is what? C is together as a unit. So they are different what? Functional groups. This is an aldehyde, and this one is called formyl, right? But this whole thing is called what? Aldehyde. And this is always carbon number 1, no matter what is inside. We don't care. But that is my carbon. And please, when you name aldehydes, don't put 1 al. What is the name of this compound? It's 3. It's propanal. This is wrong. Propan 1. This is very wrong. There will never be propan 2-al. It doesn't exist, so I can't even write it. The rule for aldehyde is that that thing is always on carbon number what? 1. So please don't write propan 1-al. It's wrong. This one doesn't have a positional isomer. For me to get a positional isomer, then I need an extra carbon. In fact, an extra carbon still doesn't give me a positional isomer. So, guys, they know the questions to ask you. Are you aware that this doesn't have a positional isomer as well? Because by the time I bring this guy here, it is still 2. I number from this side. No. Okay, let me see. Do I need one more? Yes, I do. So they won't ask you ambiguous questions. It will be very clear. All right? So are we okay with the difference between aldehyde and that? So please, we don't say propan. Let me clean it. It's irritating me. I'm saying propan 1-al. It's like saying ethan 1-all. Can you have ethan 2? No. Ethan 1-all is wrong. It's ethanol. Because whether you put it here on the right or put it on the left, it is still what? 1. You cannot have ethan 2. Or is it making sense, please? But you cannot write propanol. Hold on. Because it could be 1 or 2. That one you must specify now. Propan, because there are 3 carbons. It could either be on carbon 1 or carbon number 2. So you've got to specify now. Propan 1 all or propan 2 all. So when you write, just quickly look at the structure. All right? Yes.
So an alkene and an alkyne. You know, we always say ethene.
Mm-hmm.
So you know, for prop 1E, we always say. Can't you also just say propene? Because either way, it will be prop 1E.
Like for example, like that, can we have 2?
You can't do it.
So for structures like that, the one is unnecessary because you cannot have the other one. I hope it's making sense. That's real chemistry. All right. The prop 1 al. Yo. Yeah. Okay. Guys, are we okay so far? Please, let's avoid those mistakes. Are we okay? Now, it says structural formula of its functional isomer. Wait, what did we say D is? Oh, aldehyde. I think I have answered this question again today. The functional isomer is a ketone. And I'm sure right now we've overemphasized that. 1, 2, 3, 4. All you need to do is to bring that thing inside and you're done. Can I move on? Yes. All right. I drew that. The only thing was I used 3. Okay? So are we okay? Look, it's 4. Throw it inside. Okay, beautiful. Compound G, IUPAC name of the chain isomer. Let's look at G. What is G? Butane. Aha. Butle. I think this was where we were playing on that day, where we were trying to a chain isomer. Was it butane? Okay. Somebody wants to draw an isomer now and then does this.
No.
Guys, this is still a chain. 4. This is still a chain. 4. You are drawing. No, I want to show that there is 2 chains. Check this. Check this. Check this. You are drawing the same thing. You are basically drawing the same thing because it's still 4. And then you feel, oh, I've just shown the examiner that I can draw structures. No. All right. Please, I know some of you have been doing fancy things in the year. Tomorrow's paper, don't be fancy. Be raw. Straight. Okay. All right. 1, 2, 3, and then simple. Let's be simple enough. Is that fine? All right. And please draw the hydrogens. Okay. Remember, I have 3 hours, so I've... Oh, they want the IUPAC name. So what would it be? 2-methyl propane. Lovely. Now, combustion reaction. Please, all the pictures I sent to you today, as I was teaching, if you can go through that slide, I promise you, your organic chemistry is sorted, organic reaction is sorted, rate of reaction is sorted. In terms of concept, just go through. You just be copying and pasting from there. When alkanes burn in oxygen, what do we produce? Carbon dioxide and water. All right. Now, what is butane? It is C4H10 plus O2 to give us what? Carbon dioxide, and we just need to balance this, right? Okay. I don't remember if you would remember what I did the last time. I start with a 2. 2 times 4, 8. Then I go to my 10. Copy and paste. 10. 8 times 2, 16. Plus 10 divided by 2. 13, right? Please remind me. I sent a question on the group today. Empirical. I need to do it. Yes. What? Check 2018. Because one boy in that class was saying, no, it's whatever. I said, okay, please, Check from 2017 to 2020, you'll find it there. When he was checking, he found it in November 2018. Yes. All right.
It's the thing when you roll the table and then it's mass and then you ratio it. No, not that other one. No, because you ratio it and then you simplify the ratio.
Okay. Because the answer I get using that, but it's not the same. Okay, Leslie. I'll get to acid and base quickly. I'll run, and then you can just please check on the question. I'm not sure. All right. Okay. Are we okay with the balancing? Please. Alkanes plus oxygen would give us carbon dioxide and water. I'm done with this question. Is that okay? I'm going to do that now quickly. Okay, I think I do have that picture here. Okay. It was saying, please listen, carbon has what? Carbon has 86, what? 96%. And hydrogen has what? Percentage composition? 13, what? 04%. Is that fine? And the molar mass, the molecular mass, I'm just going to say mm, is 138, I think. 138 grams. 2 questions. Determine the empirical formula and the molecular what? Formula. All right. I know that it's a long time ago, but we need to know this quickly. How do we determine? There are so many ways, but please follow what I'm going to do. We start by, I write this, carbon and what? Hydrogen. Is that fine? Then I would write the mass. Because this is percentage by mass, we can just say it's equal to the mass as well. All right, so what's the mass of carbon? 86,96. And hydrogen is what? 13,04. I actually created this question with one question that I saw there. Then I'll go and write the atomic mass. So I'm just going to write molar mass there. Go to my periodic table. Carbon is what? 12. And hydrogen is 1. We remember that, right? Everything has to do with number of moles in chemistry. So what is my N? Mass over molar mass. What do I have? 86,96 divided by 12. 13,04 divided by 1. What is your answer? Quickly, calculators. Sorry? I've changed it into mass. There's no percentage now. Yes? What's the answer? 7,25. I don't need a calculator for the other one. Thank you very much for your calculating. 13,04. All right. Thank you very much, Bibi. All right. Now, I look for what? The ratio. When we look for the ratio, what do? We divide by the smallest. Is that fine? Which one is the smallest? 7,25. So what is 7, let me just write it here so when you revise. 7,25. And then what? 13,04 divided by what? 7,25. What is this? 1. What would this give you?
1,8.
Please, don't round off as 2. It's not 2.
1,7980.
Okay, 1,7980. 1,8 is still fine. It's not 2. Okay? So, 1, what? 8. You know what this means? This means for every 1 carbon that we have 1,8 what? Hydrogen. For every 1 carbon, we have 1, but you cannot write that like that. It must be a whole number. Is that okay? How do you get this to be? Are we okay so far? It's coming back to mind, right? But I'm sure. You don't remember this? No. Please, you'll see that I'm going to convert it now. Please just watch what I'm going to do. It's 1,8, right? Please don't write 2. It's different. Once you write 2, you are writing a different compound. Now, let's check what we're going to do. Change this 1,8 into a fraction. That's 18 over 10. Great. Why are you guys looking at me? That's grade 10. Good. Simplify 18 over 10. 9 over 5. So what do I have?
How did you get that into a fraction?
One. Geez, what's wrong with you? What's wrong with this child? There is 1 comma after the 0. There's 1 digit after the 0. It becomes 18 over what? 10. 1,8 is 18. I'm changing it into what is 18 over 10? It's 1,8. Guys, I know you're done with maths. Please. Wait. Okay. Can we change 2,5 to a fraction? It's going to be 25 over 10. And if you divide this by what? By 5, it gives you what? 5 over 2. Yes. Yo, these people. Okay, use your calculator. If you press 1,8, I'm sure your calculator can do that for you, right? All right. 1,5 equals to 1,8. All right, 9 over 5. So can we, God of heaven, 9 over 5. Is that fine? Now, we need to change all of this into what? Whole numbers. What do? Multiply both by 5. What do you have? C5, H9. That's my molecular what? Formula. No, sorry, that's my empirical formula. Why? It is a ratio. Now, check something. Somebody who decides, I'm going to round up. I don't know how to do this thing. And this is Fahima. Now, this is 2 and 1. What are you going to have? CH2. They are different. This one you are saying for every 1 carbon, there is 2 hydrogen. We are saying for every 1 carbon, the H is not complete. It's 1 comma. This is BB's H.
Why wasn't any empirical formula in our chapter?
Because it's a science.
I don't know who set the paper. Empirical, I'll give you the difference between empirical and molecular. Empirical. Okay, guys, please, I'm going to post this lesson. Please rewind and quickly go over this. Please and please and please. It is there. If you have your papers, check November 2018. You'll find it there. Convert the story into what I did. All right, please. This, they expect you to have done it in grade 10, revised it in grade 11. So it's a carryover knowledge. All right. Empirical. So empirical is what? The ratio. So for example, this is the empirical formula for all alkanes. No, for all alkenes. What's the formula for alkene? CnH2n. Divide both sides by n. Divide the 2 by n. CH2. What is the okay? Let me give you an example. What is the molecular formula of butane? That was alkene. Butane. C4H10. This is a molecular formula. It shows you the exact number of atoms present. Now, what is empirical? Empirical is a ratio. Can I divide both by 2? What do I have? C2H5. The empirical formula will remain the same for all alkanes. Check. Give me another alkane. C5. No. What am I saying? All right. It won't remain the same. Sorry. C5 what? H12. Can you divide that? No. That's your what? It's both the molecular and the empirical. If I have C6H14, can we divide this by 2? Empirical is always a ratio. Thank you. The simplest, in fact, we define it as the simplest whole number ratio in grade 10. What is this? C3H what? 7. Because I cannot divide further. Hold on. Let me show you something where I got. Wait. Wait. No. I'm not jumping. Okay. Just leave me alone. Who's right? By saying what?
By saying if you can't solve it, you can just go to the next page.
Okay. Just a second. This is 2022, June 2022. Which one did I send to you? I think I sent this one, right? May, June. 1 second, please. 1 second. Where did I get this paper from? And I threw everything away. But this question, this thing came from a 2022 paper, although they didn't ask them to calculate, but they told them to write the empirical formula. Just 1 second, please, so that... just 1 second. Wait, one second. May, June. Paper, no, it's paper 2, right? We did it paper 2. Okay, paper 2. Where's this? Just 1 second, guys. I'm sorry for taking your time, but I think if we see this, Leslie, I cannot jump to acid and base, please. Yes, no, we never round up. Okay, guys, please look at this. Quickly. All right, please check. Look at this. This is 2022. And that's what made me revise how to No, wait. Here, you have a molecular formula. That's why this is 1 mark. They said, write down the general term of the underline, whatever it is. Is P saturated or unsaturated? This is what? Unsaturated, right? And from here, we can simply count. How many carbon atoms do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many hydrogen do we have? 1, 2, 5 there. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is it 19? No, 18. Okay. 1, 2, 5. 1, 2, 3, 4, 5, 6. No. Hold on. Okay. They made a mistake. Check this compound. Okay, hold on. They made a mistake there. All right? Baby, now you know. There. So this one will have affected a series of questions, right? Okay. So I hope we are able to pick the mistake. Do you see the mistake? There's no way to put the 2 there. All right. So this is what? C10H what? Now what is this? Molecular what? Formula. What is the empirical formula? C5H9. This was what I used in creating that question. Just to revise empirical what? Formula. All right. They gave you this, but now it comes as composition, and then you must get empirical what? Formula. All right. So please, do you see my empirical formula? How do I then go to what? Molecular formula. Please, I am going to calculate the molar mass. This is 5 marks or so. Molar mass of the empirical formula. How many carbon atoms do I have? How many carbon atoms do I have? 5. So this is what? 12 times 5 plus 1 times 9. What would this give us? 69. The empirical formula is 69. All right? Empirical formula, empirical mass is what? 69. What is our molecular mass? 138. We are going to look for a ratio, and the ratio is molar mass over empirical mass. What's our molar mass? 138. What's our empirical? 69. It's a ratio. You were looking for what you used in dividing. We divided by 2. All right? That's how the question came. So my ratio is what? 2. So it's 2 that's how I got this thing, remember? It is what? C10, H what? 8. That is the molecular, and that's the ratio. Do you see that the division is 2? That's the 2 you are looking for there. All right? So it's 2 times that. So you multiply each compound by 2. Don't worry. I can send you a few empirical formula questions. I have lots of them from grade 11 paper. Just for you to practice too. Which one? It's 100%, so it's just mass. It's percentage by mass. All right. So just change it to mass. It's fine. All right. Okay. We are done with that question, right? Fast, boy. Guys, we are done. Can we go to what? We go to before reactions. We go to boiling point end. All right. Please, again, if you can just go through that slide I sent, you would be able to answer all your questions. All right, quickly. Let me answer this question. People. Learners investigate factors that influence the boiling point of organic compounds. Listen, there are 4 factors. Molecular mass, the intermolecular force, the position of the functional group, and the 4th one is the chain length or the shape. Chain length, surface area, shape. I sent that note today. Please go back. I keep repeating. That note, when I wrote it, it was so good. I said, no, I cannot give these kids this alone. And I sent it to all the groups that I have, close to almost 1,000 learners. I just kept sending because those notes. When I did that, and learners went there to answer questions, they were just referring, and they're like, "Oh, okay, everything is here, done." So what their job today was just to go over that note. So please also go over it. Now, if I look at these 3, something is common. Oh, in fact, the 4 of them, they all what? Alkane. You know what it means? I have something common, which is called the control variable. What is the controlled variable? The homologous what? Series. Because they are all what? Alkanes. No, if they say methyl, but that means they are putting it on. It can only be 1. It's 2. There's no 3. There's no 1 either. So it's just 2. 1, 2, 3, 4. So it's either 2. If you think you are putting it on 3, then we change the counting position now. It's still 2. All right. So please, what is the control? What is constant? What is controlled here? So for this one, my controlled is what? Functional what? We can even say functional group because they are all what? Alkanes. Now, what is the independent variable? What are we changing? We are changing the chain length. This is 3. This is 4. This is 5. And that is a side chain as well. So whatever you are changing is the independent. Independent starts with the what? Independent starts with the letter I. What am I changing? Controlled. What is kept constant. So if you see that, for example, if I consider these two, do you know what is kept constant? Molecular mass. Do you see that? And within these two, just these two, what are we changing? Chain length. I don't know if it makes sense. Because chain length here is 5, chain length here is what? 4. And these two are isomers. I don't know if you see that. Meth is 1. But is 4. 1 plus 4. Meth plus but is pent. If you understand the mathematics of chemistry. Right? Does that make sense? Meth plus but is pent. So we are changing what? Here we said molecular mass can also fit in for what? Controlled. Is that fine? Because they are both what? 72. But what are we changing? We are changing the chain length. The chain length here is what? 5. And the chain length here is 4. Make sense? All right. Are we good? And we know, I'm just saying so many things that I can say and just bring you up to speed. The longer the chain length, the more the net intermolecular what? Force. More energy is then what? Required. And then what will you say? The boiling point increases. It's all in that picture that I sent you today. All right. Can we compare this and this? What's the control here? The number of carbon atoms as well. You can even use chain length. So they are both if. So if they ask you for what's controlled, number of carbon atoms. What is the independent variable? The functional group. And because they have different intermolecular forces, you can also say intermolecular force. What is present here? Hydrogen. What is present here? Dipole. Yes. Dependent now is the result we get. So this is our dependent what? What are we saying? Boiling point depends on intermolecular force. Boiling point depends on chain length. Boiling point depends on the shape. So boiling point becomes our dependent variable. All right, let's answer quickly. Boiling, please, 3.1. If you don't know it, good luck now. Yeah. Okay. The boiling point of compound ABC are compared. Do you see why they are comparing ABC? You cannot compare when you have two variables changing. It's wrong. So they are comparing what? A, B, C. Why? They are straight chain and they have what? They are all alkanes, same functional group. Is it making sense? All right. How do the boiling point... I don't know why they ask such questions though. But they must just give you 1 mark. But I want to answer one question that when we mark, I see that learners get this wrong. Just here. How do the boiling points vary from A to C? Badna. I hate. Wow, you guys got that right. Yeah! Like, really? Okay. They should collect the paper from you. You must leave the matric exam. I mean, negative 42. And in fact, to help you, there's a positive 36 here. If they are going to mess you up, they should put the 36 inside there. And, but, okay. Don't let me talk. Explain the answer. Then the question they would have told you to which one, explain the question 3.2.2 would then come in. The structure of the question would then change to say arrange or explain why there is an increase in boiling point, something like that. Guys, how do we answer 3.2.1? Explain the answer to question 3.2.1. Normally we use the ICE. I think I once studied about the ICE, identify, compare, and what? The energy required. All right? ICE. If I were to identify this, what would I say is present? Do you see it's all alkanes, right? So I cannot really talk about London. What's changing? The changing one is now the what? the chain length. So I would say, they said it's increasing. A has a shorter chain length than B and then C. Just put the then. Okay? What happens if it has a shorter chain length? The point of contact of forces becomes what? Small. The net intermolecular force in A is weaker than in B, than in C. Therefore, the energy required. Makes sense, right? You can also add that. There's always options. Don't write everything. Okay. Slash surface area, slash. Okay, well done. Okay. Here is the question I want to quickly check with you. At 20 degrees Celsius, what phase? There. It's 1 mark. What phase is A, B, and C at 20 degrees Celsius?
So at A and B, it is liquid.
A and B are gases. This thing will boil at negative 42. We are now at 20. It has dried. It's dried up, disappeared. Even the smell is gone. Because it will boil at negative 42. Right now, the temperature is 20. It is way, way below the room temperature. It has gone. What about negative 0.5? It's a gas. What about 36? It's a liquid. Because this one will only boil at 36. Where are we? 20. We're still coming. Why? Use the boiling point. The boiling point, this one would boil at what? 36. What's the temperature now? 20. It will only boil when it gets to 36. No, they give you a room temperature. You compare with the room temperature. They will tell you, is it a gas or a liquid? What's the boiling point of this one? 36. You have option, whether it's a gas or a liquid. Boiling point means it is changing from what? Liquid to gas. It will only boil when the temperature gets to 36. It's like water. Water will boil at 100. But the temperature is now 40. Is it a liquid or a gas? It will only change to a gas when we get to the boiling point. Did it make sense though? Is it making sense? All right. So I know that 1 mark, people just get, this one. Yes, Mary, you can. No, it's not only when it's branched. Mary, did you get the pictures I sent today? We can also use surface area when molecular mass increases. Because if I say molecular mass is increasing, I am adding X. Let me just explain something there quickly. Look at this. If I have, and in the pictures that I sent, I actually used a particular compound. But let me do something else. Guys, look at this. Look at this. Can you give me the molecular mass of this? Yeah, the molecular mass of this. Carbon is what? 12. 12 times 2, 24. 24 plus 6, 30. This one is what? 30 grams per mole. Is that fine? Now, if I were to add another, I have increased the molecular mass. By increasing the molecular mass, what am I doing? I am putting extra atoms. We don't expect the chain length to be the same. The chain length will be what? Longer. Biggie, you look confused with what I just said. I have added this. So what happens? The higher the molecular mass, the longer the chain. 12 will give us what? 36, 37, 38, 39, 40, 41, 42, 43, 44. This one is what? 44. Do you see that already? As the molecular mass increases, the chain length is also what? Increasing. Make sense? And let's do some nice chemistry. How many points of contact forces do we have? There's a force here. 2, 3, 4, 5, 6, 7. 7 points of contact. If I go to this one, how many points of contact? 1, 2, 3, 4, 5, 6, 7. Oh, now we are the same thing with that. But what are we doing? Adding extra. Which one is going to be stronger? That. Adding more atoms means increasing molar mass means you are adding more atoms. What happens to the chain length? What happens to the chain length? It increases. Once that increases, the point of contact of intermolecular force will also what? Increase. If it increases, what happens to the net intermolecular force? It's now stronger. I don't know. You all are city people. You use these brooms that you stand. When I was growing up, we have this. Let me Google the Nigerian broom for you. It's on that. Go. Oh, you know it. Look, this one is a city. This one use a vacuum. They use vacuum cleaners. You don't know the broom. Uncle Siam. You know the broom. Okay. Let the. Huh? All right. Let me Google a Nigerian broom. Hey, bye. Yeah, no, I'll just search for a broom. Let's. Please don't write Nigerian broom in tomorrow's multiple choice. You see, they give me these white people things. No. It's what? Let me say brooms. Broom. Where? Yes. I grew up sweeping with this broom. And it's my mother's favorite. She can just swing it where you are. Check this. Okay, guys, it's 14 rand. Oh, we can buy it, ne? I think it should be in every lab to explain intermolecular forces. Good. Okay, listen. Why explain intermolecular force, right? One broomstick is so weak. It's like a London force. You can snap it with just your fingers. But the more I promise you cannot break that thing. So the more, listen, I hope it's making sense. The more you add those things, it becomes what? Stronger. Yeah. But so, guys, is it making sense? That as we keep adding the weak intermolecular forces, that's why I use the word net intermolecular force becomes what? Stronger. All right. But please, but anyway, guys, we're getting the whole idea, right? Okay. So, wow, what a class. The boiling point of compound B, C, and are compared. The boiling point of compound B, C, and D are what? Leslie, what are you saying? You should be here, Leslie. Okay, B, C, and D are compared. Is this a fair? I told you what we mean by fair comparison, right? You only compare one variable. Let's go check B, C, and D. Are we comparing one thing? No, we're not. It's B, C, D, right? Are we comparing the same thing? No. The chain length. Are they, okay, wait. What are we comparing here? B, C, D. What's common? It's alkane, alkane, alkane. But hold on. Here, we are comparing what? We are comparing straight chain here of different number, carbon atom number, right? And here we bring in what? A side chain. It's not fair. There are too many what? Variables that are being compared. Make sense? All right. Too many variables. It's like somebody who has not eaten and's got a leg pain. And then you ask him to run with somebody who has eaten and has a car. All right. Choose your answer. We'll say no, right? Give a reason. More than one variable is being tested. Compounds E and F are compared. State the independent what? Variable. I think we answered that already, right? What was the independent? Independent is what we are changing. What are we changing there? Functional group. They are different functional groups. Okay. What are we checking? Write down the name of the strongest fan that was present in F. What's the name of the strongest present in F? It's a dipole what? That's all you need. Don't start trying to write extra names. Which compound, D or E, has a higher what? Vapor pressure. The one that has a higher what? Boiling. Please don't say they are inversely. They are not inversely proportional. No, they are not. What? Don't say they are inversely proportional. They are not inversely proportional. If something is inversely proportional, then I must be able to calculate from one. There's no constant there. We just know that as one is increasing, the other one is decreasing. It's like bread and petrol. They are not inverse. The price of bread and the price of petrol, they are not in. All we know is okay, bread goes up. Okay, fine. But we cannot say they are directly proportional. Because if I tell you that petrol is going up by 10 rand tomorrow, do you know how much bread will be going up by? Okay. So if we cannot calculate it, we cannot use the word direct or inverse. And remember, directly means 0, 0. It must start at 0, 0. Even if petrol is free tomorrow, they will still sell bread. Okay. All right. So which one has a higher vapor pressure? The one with what? A low what? Boiling point. Is that okay? Yeah, no, I'm just explaining, baby. Easy. D or E. Now let's check. Which one has a higher boiling point? E. Can you explain why E has a higher boiling point though? I, C, E. Can we identify? Okay. All this extra sentence you are adding in the form of, can you just make it easy? E has hydrogen bond. Okay, thank you. In the form of, you are still writing in the form of, somebody's done by saying E has hydrogen bond. F has dipole. 1 mark. Leave, we all know it's intermolecular force. Intermolecular in the form of. Can we compare? Hydrogen bond in E is stronger than the dipole in F. More energy is required to overcome the intermolecular force. We don't break the force. It's not a relationship. Forces, we overcome forces. We're talking about intermolecular what? Force. We overcome intermolecular force. All right. Therefore, then you make your conclusion. Guys, it's straightforward there. There was something that I wanted to say right now and I skipped my mind. But anyway, all good. Organic chemistry is looking awesome. Another 12 marks. Let's check this one. Organic reactions. Guys, please go back. It's very simple. Go back to that page. Did you all receive the pictures I sent today? Please, if you can open that picture right in front of you now, you will see all your answers. And the best thing is to draw if you are lost. Compound P and Q are organic and T is an inorganic compound. Write down the type of reaction. Check this. I'm using concentrated. Do you remember CEDS? When I use concentrated, it is what? I'm done. Elimination. Please don't write elim.
No, it can also be substitution.
It cannot be substitution. There's a condition there. Concentrated. Whatever you want to say now, please throw it out of the window. When we use concentrated, please, it is what? Elimination. IUPAC name of P. Please don't even try to wave it around. Once you use concentrated acid or base, the end product or the reaction is what? Elimination.
In hydrolysis, we use a concentrated base.
All right. All right. Please, if it is concentrated acid or base, it is what? Elimination. If it's dilute, strong base, then it is what? Substitution. Please, those of you in class right now, I hope you all got the notes. Okay? You all got the notes that I sent today. Everything is in the slide that I gave you today. Everything is in that slide. All right. Can we please answer? And when you are eliminating, what do we do? The poor gets what? Poorer. What does that mean? All right. We remove. This is Zytef now. It's not the same thing. Markovnikov is addition. The rich gets richer. Zytef is when you are removing. Okay?
So in her state, you're removing BR and replacing it with OH.
We're not replacing. Concentrated. What is it? Once you are replacing, it's substitution. Okay, baby. No. I want you to get it. When you say replace, what happens? You substitute. You take one out and throw one in. It's different from elimination. If there are 10 people in class and we replace you with someone else, how many people do we have in class? 10. If we chase you away, how many people do we have in class? 9. Eliminate means to remove. That's why we say delete. Make sense? But when we say, do you watch soccer? Yeah. Good. When a player is tired, what do? We don't remove him. We replace. And they are called what? Substitutes. Oh. And that process is called what? Substitution. Is that okay? But the key word here is what? Concentrated. And once you see content is elimination. What's the other condition? Strong heat. Guys, if you are eliminating, you don't go in smiling. I want to chase you from my chair. And I'm saying, oh, Tess, please stand up from my chair. Oh, Tess. If I want to send you away, I need to chase and be strong, right? Strong heat. All right, so condition is what? Strong heat. Is that making sense? All right. Now, what do we remove, please, people? Definitely we are going to remove BR. Okay, so let's go through the removal system. We are going to remove what? BR. Please, Don't be wicked. Don't remove Br and still remove hydrogen. Pity the carbon. You are removing somebody's 2 legs. No, at least remove one. Okay? We've taken Br from here. Can we be fair enough? The question now is, which hydrogen do I remove? I look at the adjacent ones. It's either this or this from this carbon, right? But I remove from the one that has less. That's why I say the poor. Don't consider this one. These ones are hiding somewhere. Leave them. All right? Now, we look at this. How many hydrogens are here? 3. How many is here? The poor gets what? Poorer. We get this guy out. Does that make sense? We're good. Making sense, right? Lovely. Now, if we remove that, please, when you remove, don't put it under the table. It's a reaction. Is it making sense? How did we remove? We removed by using what? Concentrated. And guys, check something here. This Na plus and OH what? Every time OH smells that there's H around, our water is coming. So what are we going to form? We are going to form, let's look at the structure. Are we okay with the removal system? What are we going to form? Let's draw. 1, 2, 3, 4. Are we fine there? That still continues, right? I'm just going to write CH3, please, people. And then I have what? H. Is that fine? And then I have CH3. I have H. There's something wrong with my structure, though. Remember, I have removed these 2. So I need a double bond. Make sense? That's why we say what? S-U-E. From saturated to unsaturated. It is what? Elimination. So we are changing. This is a saturated organic compound. All right? Saturated organic compound. This is what? Unsaturated. Are we okay, everybody? Now, plus what? We have removed HBr, but OH is smelling H somewhere. What are we going to form? Water. All right, let's do structures. Please, just to remind us, if it's water, then you must draw that, right? Is that fine? Plus what again? Remember the sodium. And there was a Br. Na. Check how chemistry can be so nice. We have our NaBr. This is the major product. That. And what is T? Just compare, draw structures, and check the rule. You'll be fine. Does that make sense, everybody? Idris, you look dazzled. Check your note, check the thing, check the picture that you have. Open it. You have it? Yeah, it's there. SSS, saturated substitution, SUE, and that's all. USA, CEDS. When you have concentrated, you eliminate. When you have dilute, you substitute. We're done. Simple. Use that. It works all the time. And in that note, again, I gave you where I wrote catalyst to use when you are doing addition reaction. IUPAC name of P. Can we name this? It's an alkene, right? And this guy is sitting on carbon number 2. So what do we have? 2-methyl but 2-ene. 2 marks. Name or formula of T. Okay, both of them are correct. Both of them are correct. Name, water. Formula, H2O. Make sense? Look at reaction 2. What is this? What is that? It's an ester. What is the name of this carboxylic acid? I have 2. Ethanoic what? Acid. By the way, I see my ethanoate here from there. Where is my butyl coming from? So this is what? Butane, 1 all. We always use primary alcohols in esterification. Which other alcohol are you talking about? it's not just, it's just know that it's a primary what? Alcohol. All right? So even if they give you a secondary alcohol, we convert it first to primary alcohol, and then we do esters. What is a primary alcohol? Let's quickly look at primary. What can somebody define primary alcohol? I heard nothing. Yes, sir? Nope. Nope. Guys, now you are talking. It is no. If you tell me that the OH is connected to one carbon, it doesn't make sense. The carbon atom connected to this guy is connected to one. So this is where the name comes from. This is called a primary carbon. That's why we call it primary what? Alcohol. So if this is not there, they are going to mark you wrong. The carbon atom connected to the OH is connected to 1, primary, 2, secondary, 3, tertiary. So for example, if I have this, how many is this carbon connected to? 1, 2, 3. It is now what? Tertiary, or they can do that. All right. So please, I need us, and it's not only alcohols. We could also have haloalkanes. All right. Zintle, you need help with me writing it down. Okay. Primary alcohol or haloalkane. It could be any of the two, right? So we say the carbon atom attached to the, now it could either be the hydroxyl, which is OH, right? Or if I'm using haloalkane, the halogen is attached. There must be two attachments. Okay, let me do this. 1 carbon, I think I can just do this. Primary. Let's use one definition for all. 2 carbons. I hope you see what I'm doing, right? Secondary. And what? 3 carbons. Tertiary. Did it make sense? We could also have we could also have primary haloalkane, secondary haloalkane, or tertiary haloalkane. Really? Okay, that's why you came. All right. That's why you're here. Sorry, 1 second. 1 second. Let's leave this broom. I just want to check something. I want to check something quickly. Okay, check here. Check here. I know I saw this as well. Look at 2.3.2. Give a reason why compound C is classified as what? A primary haloalkane. Okay.
So then when you say
It's the same thing. The only thing that changes is what? You are no longer talking about what? You are no longer talking about hydroxyl. You are talking about what? Halogen. That's all. So it could either be an alcohol or a haloalkane. Everybody okay there? Or haloalkane. Are we okay? Can I move on? Okay. Okay. Okay, guys, please, when it comes to esterification, I sent a small, again on the small note, what do we need? Concentrated what? Sulfuric acid. Why? It is a strong dehydrating agent. Dehydrating agent. And please, we never put on direct flame. Why? Alcohol is flammable. Don't say alcohol is fire, please. Alcohol is flammable. So how do we deal with it? Cornelia, yeah, you're laughing. No, people, guys, I'm talking from marking experience. The things we read. Someone says alcohol catches fire. Plus carboxylic what? Acid will give us what? Esters. And let's run. So we finish. In the presence of what? Concentrated sulfuric acid. And this is done over a water bath. Guys, this is done over what? A water bath. You know what a water bath is, right? We have a bowl and there's water and then we heat. Your test tube is inside. Your test tube must be inside. How do you know an ester is formed? Pleasant smell. Esters have what? A pleasant what? Smell. And most of them are oily. Okay, guys, I think if please go and use that slide I sent and try other questions. Things become very easy. One thing that I know they'll ask you tomorrow is cracking. Cracking. Please, again, I'm just referring you to that. I'm just going to talk through so I don't waste time. If you have that slide with you, cracking is what? The chemical process where longer hydrocarbons are broken down into smaller usable. And there are only two possibilities. When alkane can either break into alkene plus hydrogen, alkene plus hydrogen, or alkene and alkane. The numbers could be anything as long as it works perfectly into the equation. You are not going to say, so there could be many options. That's what I'm trying to say. All right? All options, as long as the numbers are going to be what? Correct. And there are two types of cracking. Thermal cracking and what? Catalytic cracking. Thermal cracking, what are we using? Heat. So the condition is what? Very high temperature and very high pressure. For thermal catalytic, what do we need? A catalyst. Let's answer this question. The cracking of long-chain hydrocarbon C10H22 takes place in a test tube as shown below. Cotton wool, so there's no heat here. So this is what? A catalyst. Is that okay? It's either thermal or catalytic. This one is what? Catalytic. Two straight-chain organic compounds X and Z are produced in the test tube. Again, I did explain saturated versus unsaturated. How do you check which one is saturated and which one is unsaturated? By using bromine what? Water. The bromine test. For saturated, color will remain brown. But for unsaturated, it becomes from brown to colorless. Okay, let's just quickly answer this and get on. State the function of Al2O3 here. What is this? It's a catalyst, right? Okay. The organic compound X and Z are now passed through bromine water at room temperature in the test tube B. Only compound X reacts. It means X is an alkene. That's the key there. Y or Z will therefore be what? An alkane. Apart from the bubbles being formed, state another observable change. We just mentioned that, right? From brown to colorless. Bromine, spell bromine, B-R. Spell brown, B-R. Remember that way. Bromine is brown. Bra. Okay. Alkenes. Alkenes. What are alkenes? Thank you. Unsaturated will change the brown color to colorless. I remember that I even played a video. I played a video. The one that did not change is saturated. Alkenes change. Bromine is brown. When you use unsaturated, brown Bromine changes into what? Colorless. All right. Write down the type of reaction that takes place in test tube B. Already we know that the one that goes in there is an alkene. So, and it's unsaturated, right? There's only one reaction for unsaturated. Addition reaction. We're done. Write down the molecular formula of Z, please. Now, Z, we said, what did we say Z is? It's an alkane. You can write any alkane you want. So, give me the first possible alkane. C2H6. You'll be marked correct. Somebody would write C3H8. They'll be marked. But please make sure when you are writing, you are doing the maths. So, those two are possible. Why? If these two, okay, this is my Z. Let's write X quickly. Let's write X. How many carbon atoms have I used? 2. How many do I have? 10. So what do I have left? Okay, I'm going to show you something there. 22 minus 6. What do I have? 16. But hold on. The examiner says 2 there. So it's what? 2C4H8. Can you see it's an alkene already? You cannot leave it as C18 because the examiner tells you it's 2 moles. So how do you get 8? 2 times 4, 8. 2 times 8, 16. If somebody had used this one, can you quickly tell me what is my X going to be? Use this as Z. Everybody, quickly, very fast. That's an alkane. If somebody used C3H8, what will be? Those of you at home, please send me answers as well. We should be done. All right, let's mark. Are we ready to mark? Fuman, what's your answer? Okay. All right. I see what you're saying. So we're going to get a 7 there, right? And we don't want to because it's 2 moles. So that means that C3H8 might become a problem, right? Okay. So I think we can then change this one into what? If we use C4, will it work? Even that one was an alkane. C4H10, will it work? How many carbon atoms do we have left? 6. So what do we have? C3. No. C. No, I've already divided. That's the thing. Because I've already divided. Z. So what is our X going to be? I'm left with what? 6 carbon atoms. But there's a 2 in front there. So what do I have? C3H. 22 minus 10 will give us what? 12. But there's a 2 there. Why are you confused now? That's the formula. Guys, Are you confused with maths? C10 H22 2x plus Z. This is an alkane. That's an alkene. We said if we use C4 H10, how many carbon do we have left? 6. But there's a 2 here telling you it's 2 moles. So what do we have? C3. Because that 2 multiplied by 3 would give me the 6. And then H what? 22 minus 10. 12. But there's a 2 there. I cannot write 12 here because of that 2. So what do I write? 6. Done. So when you add everything here, it must give you this. 2 times 3, 6, plus 4, 10. 2 times 6, 12, plus 10, 22. So I gave you the 2 possibilities of cracking. Alkane and alkene, or alkene, alkene, and what? Once you see double alkenes, hydrogen is involved. Let's prove it. All right. If we were to have, if the examiner tells you X plus Y plus Z, automatically there's hydrogen now. Okay? All right, so hydrogen. These 2 will have to be alkenes. Let's try. C3, what's the next alkene? What's H? 6, because it's double. Plus, now, how many have I used? 3. How many am I left with? 7. C7, H14. Automatically, it should add up. What do we have? 3 plus 7, 10. Are we fine there? 6 plus 14, 20. Plus 2, 22. We're done, guys. It is very, very easy and very straightforward. Learn the definitions. There's thermal and there's what? Catalytic. All right, let's go to rate of reaction. Let us use the reaction of magnesium carbonate with excess dilute hydrochloric acid to investigate the relationship between temperature and the rate of a chemical reaction. The balanced equation for the reaction is given as that. The graph obtained are represented in the graph below. Now, the first thing that defeats you is we are not used to this graph. It's kind of different. Please check what's on the Y and check what's on the X. Now, what's on the Y? What's on the Y? What's on the Y? Average rate of what? Production. Of what compound? Carbon dioxide. What's on the X? Temperature. Now, define reaction rate. We all should know that, right? The change in concentration of product or reactants per unit time. Guys, if you are missing those definitions, we are taking the A away from us ourselves gradually by ourselves. State 2 conditions that should be kept constant during this investigation. Look at it. Guys, should be kept constant. Temperature is already changing. Let's look at this. Your focus should be here. For this to be, I'm dealing with a solid. What affects a solid? Surface area. I cannot use powder and use granules and expect the same result. No. So what should be kept constant? Surface area should be kept constant. Look at this one. Concentration should also be kept what? Constant. Can I keep pressure constant? There's no gas. All right? You're saying why concentration? All right. Guys, are we okay? 2 things that should be kept constant. Temperature is already changing. We should not add a catalyst. Is that okay? Don't say catalyst kept constant. Catalyst cannot be kept constant. All right. You could write presence of no. Don't do one with catalyst and do another one without catalyst. Is that fine? All right. So, and why do we have controlled variables? To make experiments what? Fair. Mary, which question are you referring to? Use collision theory to explain the relationship shown in the graph. Again, check the slides. It's a copy and paste. Increase in temperature will increase average kinetic energy of particles. What? Increase. There's a point that people normally miss there. More particles now have enough kinetic energy. That we increase doesn't mean it's enough. I don't know if it makes sense. You want to buy a shoe, it costs 2.5. Somebody gives you 500. Your money has increased. But the question, do you have enough? Maybe you had 200 at the start. You are subwhelling for the shoe. All right? But you are 200. Yes, we increase it by 5. Is it enough? No. So increase increase in temperature would increase what? Kinetic energy. More particles now have enough kinetic energy. The number of effective collisions per unit time will increase. Rate of the reaction will increase. Mary, please specify which question are you referring to? 4.2, 4.2.3. If we said the last question, I don't remember the last question. I say a lot of things. The whole thing, Mary. Please specify. How do we know it's enough? It must be above activation energy. Now you are talking 4.2.4. Write down the molecular formula of Z. We know Z is an alkane, and we said work with an alkane, any alkanes that will make sure that we have a good number of alkane on that side. So Z is an alkane. So write an alkane, but before you run away from the question, make sure this alkane does what? Exist. Remember, we had a problem earlier on. We said 2 what? X. Let's see something here. 2x plus z. If somebody writes C3H8, will this work? You are left with what? 7. But this is wrong. Why 7 over 2? Because we are left with C7H what? What is 22 minus that? 14. Yes, it's an alkene. There's a 2 here. By the time I put a 2 here, I'll have to say what? And this doesn't exist. Mary, are we done? Let's cancel nicely in the exam.
Yes, sir.
All right, Mary. We cancel nicely. Okay, let's quickly go on here. The learners obtain the graph using, now this is stoichiometry. And I see this stoichiometry as 6 marks. All right. The learners obtain the graph above using what? 5 grams of that with excess HCl at 40. I think there's something at 40. Okay. At 40, what do we know? Okay, what do we know? The rate of what? Production is what? 0.5. Okay. Can I write that information down? The rate of reaction is what? 0.5 grams per, is it per minute? Per minute, right? Lovely. Of which compound? CO2. Is that fine with us? The unit will always give you the formula they used. So, I could come here and say rate of reaction is equal to what? Change in mass over change in time. By the way, what are we looking for? Time. Oh. That's what I'm looking for. I cannot get change in time. I have this. But for me to get change in time, I need to get what? The change in mass. Of which compound? Carbon dioxide. Now there's a problem. That's why it's 6 marks. I have always told you there are just 3 steps to stoichiometry. If I want to, so I need to get mass, right? How do I get mass? Number of moles of carbon dioxide will be equal to what? Mass over molar mass. Are we there? The, yeah. At 40, the graph did not end though. Okay. Now, they will not give you the number of moles of what you need. I think I've said that over and over again. They'll give you information on the other substance with which we can calculate what? Number of moles. Which compound do we have information of? It's there. 5 grams of what? MgCO3. Okay, let's go. So we need number of moles of that, right? Because all of that reacted. So what is the number of moles of MgCO3? It is mass over molar mass. What's the mass? 5. Can we calculate the molar mass quickly? Magnesium is 24 plus 12 plus 48. Quickly. Okay, that's your final answer, Mary. But I need you to give me what's the 84. All right. 0.06 what? Moles. Of, I like to always write what I found. Is that fine? 0.0595. Okay. Don't let's round up so early. 0.59. 0.0595 moles of what? MgCO3. Is that fine? Now, that is what we have calculated. Now, but what are we looking for? We are looking for the mass of carbon dioxide. How do we connect them? Mole ratio. So, MgCO3 and CO2. Can we go check the formula? What's the ratio? 1:1. That's how your stoichiometry works. Oliver, 1. How many moles of this do I have? 0.0595 to n. Can we cross multiply? N equals to 0.0595. Moles of which compound now? Carbon dioxide. You see, once you keep writing what you are looking for, it becomes easy. You're not confused with so many figures. Now I know that number of moles of CO2 is mass over the molar. Do I know the number of moles now? 0.0595 equals to mass over. Okay, 44. Is it 48 or 44? 44. 16 times 2 is 32. 2 plus 2, 4. Can we cross multiply? Mass. What is the mass now? 2, comma? You said 26. 2,618 grams of which compound? Remember, this is now what we produced. Our initial mass is 0. You have 0.5. All right? The initial mass of carbon dioxide produced was 0. No, we're not assuming. We are reacting. Product. Do we have this when we only have reactant? No. Product is 0. All right? You want to cook. You have Maggi. You have salt. You have, what else? You have all of those things. Do you have food? Food is the product. All of those things. You are working from the market. You just bought beef. They say, hey, I have food. No, you have meat. Uncooked. No product. So the initial mass of carbon dioxide is what? 0. Final mass. Do you know why I'm looking at this? It's because we said rate of reaction is change in mass over what? Change in time. Do we know our rate of reaction? 0.5. What's the final mass? 2,618. What's the initial mass? 0. Do we know time? No. Can you do the math for me, please? 5,24. Now we are done. And this is what? Minutes. Because we were given the rate in what? Minutes. Guys, check your stoichiometry. It follows the same pattern. They will not give you number of moles. Okay, Zintle? Okay. They will not give you number of moles of what you need. Find the number of moles of the other thing that reacted. Always it's that reacted that you are looking for. Before you use what? Mole ratio. Are we okay, everybody? Make sense? Okay. Zintle, are you still having trouble there? Okay. Now, what do we have? Calculate what? The molar volume. Calculate the molar gas volume. This is VM. All right? If 1,5, wait, they said at 40. So everything we're doing is at 40. If 1,5 dm cube of gas is what? Of CO2 is produced. I think we have everything we need. We are looking for what? Molar volume, which is VM. Do we know the volume itself? Yes. Now, all you need to do is to write the formula. What's the formula? N equals to what? V over Vm. Do we know the number of moles? 0,0595. Do we know the volume? 1,5, right? Lovely. What are we looking for? Vm. What's your answer? They said we should look. It changes. If they say at STP, then we go to the formula page and find it. What's your answer? 25, 21. 21. All right. GM cube. Are we okay, guys? Chemistry and physics. Write what you have. Go to your formula page, substitute, and you're done. If we follow those simple rules, we'll be good. Can we move quickly? Oh, lovely. Maxwell-Boltzmann distribution. All right, guys. Maxwell-Boltzmann distribution here. Redraw the graph in the answer book, clearly labeled. Now, what are we showing? Kinetic energy. On the same set of axes, sketch, please, they want to, here normally they give you this in multiple choice. And quickly, what we have in multiple choice is this. When you have that, then they will come and give you this. Know that the one below is a higher temperature. Please, T2 is greater than T1. Now, if the examiner says on the same, sketch the curve that obtained for CO2 at 20. If this one is 40, my 20 should be higher. It's Maxwell-Boltzmann distribution what? Curve. This is at why? We are saying as we increase energy, particles will gain enough kinetic what? Energy. If you increase temperature, particles will gain what? Kinetic energy. More particles will have enough kinetic energy above what? Activation energy. So please take note. They want to confuse you. You think because T1 is higher here, it's at a higher temperature. No, it's at a lower temperature, while this one is at a high temperature. Maxwell-Boltzmann distribution curve. All right. I think we're done there. 18 marks. See.
How do you do these changes to identify the disturbance?
Okay, let's look at this quickly. Initially, 4 moles of hydrogen and 4 moles of what? Iodine are allowed to react in a sealed 2 dm cube what? Container. Hold on. It must be a sealed. You cannot have a chemical equilibrium if it's not sealed. Is that okay? Sealed. It must be a closed. So Check again. I gave you, there are 6 definitions you must know here: sealed or closed, reversible, dynamic or chemical equilibrium, and those people know one, it should be 2. The state where the rate of the forward is equal to the rate of the reverse. The state where the concentration of product and reactant are constant. Please. I didn't write all the definition, but that second one, I did mention it there. Please, it's very important. All right. Number 3 definition, homogeneous or heterogeneous. Is this homogeneous? Yes. Why? Don't say same phase. Please, I mark it wrong. So just say, why? Give a reason why it's homogeneous. Same phase. Please. Reactants and product are in the same phase. The rate, not the state. Yeah, the rate of the what are you talking about? The rate of the forward must be equal to the rate of the reverse. Not states, of course. The concentration of the reactant and product are constant. Concentration of reactant and product are constant. All right. We talked about homogeneous and heterogeneous, right? What else? What other definition I want to mention? Somebody saying something there? Okay, let's look at this together. Please, already I noticed the examiner is going to refer to temperature. Is that okay? What do I know? Increase in temperature will always favor the endothermic what? Reaction. Yes. Okay. Now, homogeneous, right? And heterogeneous, we call them equilibrium. Homogeneous means reactants and product are in the same phase. When it's hetero, reactant and product are not. Let me give you an example. In the same what? Phase. An example is this. If I have calcium carbonate, which is a solid, to give me calcium oxide, which is a solid, plus carbon dioxide, which is a gas. Do you see there are different phases? So it's a mixture of phases. Solid, and gas. It is hetero. Hetero means different. Are we okay? Now, quickly, temperature. Where? Okay, let's get there. But the arrow is what? Reversible. And reversible means a reaction where the product can be converted back to the reactant. We're done. Okay. And guys, you cannot have chemical equilibrium. If I was an examiner, what I'll be asking you tomorrow is this. Give 2 conditions for chemical equilibrium to take place. It must be a closed system and it must be reversible. If it's a one-way, it is. Now I'll be very wicked. When I said, if it's one way, then you talk about rate of what? Reaction. I like what people don't. Everybody is looking for table, rice. I don't understand. But we're missing those tiny details as if we are hungry in the chemistry exam. So rice. Anyway, what do we know about temperature? What do you know about temperature? Increase in temperature will favor the endothermic. All right, let's see something. The graph shows the concentrations of, concentrations, right, of X and Y, or of H and HI. I saw Y there and I'm making it X. Exothermic reaction. Write down the value of Y. What do you think the value of Y would be? You are wrong now. It's not 4. Guys, this is 2 moles. This is concentration. And what do we have? 4 moles. This examiner is clever. This examiner is asking you, do you pay attention to details? What is concentration? Number of moles divided by volume. What is the number of moles? Initial, 4. What is the volume? 2. What's your answer? 2. Very clever examiner. A lot of people will say 4, forgetting that we are talking about concentration. Le Chatelier's principle, I know we are all good there. Changes were made to the temperature. Please, can we quickly, before we answer that question, changes were made to what? The temperature. If we increase temperature, which reaction is favored? Endothermic. And which one is endo in this case? This is what? Exo. And this is what? Endo. Is that fine? If we increase temperature, which one will be favored? Okay, the reverse reaction. Let me show you how an examiner can do that in the exam. That means the reverse is what? Favored, because it is longer. Leslie, you use Avogadro's constants to do that number of electrons. She's asking a question. Use Avogadro. All right. Exo and what? Is that fine with you guys? Okay. Let's check something here. They said a temperature was made at T2. Let's see T2. There we go. What happened at T2? This is product, right? And this is what? Reactant. Oh, the product increased, I see. Make sense? All right.
The dotted line indicates reverse reaction.
It depends on the examiner. Examiner is telling you H. This is not rate of reaction.
Oh.
This is what? So dotted lines don't mean reverse. It's just the representation. Okay? So examiner is telling us the concentration of hydrogen is what? Decreasing. And at T2, it decreases further. But the concentration of the product increased. Okay? Since concentration of product increased, you know what we have done? We have favored the forward. Because to get product, we move forward. Is that fine? And my forward is what? How do we favor exo? We decrease temperature. Because increase in temperature will favor what? Endo. To decrease when we decrease temperature, we favor what? Can I please before we okay, this is cooled, right? Cooled. There's something important that people don't realize here. To favor the exo, what do? We what? Decrease what? Temperature. Lovely. Caution. Don't decrease below activation energy. Caution. Yes, you are decreasing to favor. But once it goes below activation energy, what happens? There's no reaction. Activation energy is the minimum energy required for a reaction to take place. Now, because when you want to favor the exo, you keep decreasing, but you are not watchful of the active. Once you go below activation energy, there's no reaction.
Okay, so if they tell you that the activation energy is 2 joules and they decreased it to 1 joule,
Then there's no reaction.
then your answer will be what question they ask?
All right, I think I saw a question. Let me see. Don't decrease below what? EA. You know the reason why, right? What's the reason? Below activation energy, there is no what? Sufficient energy for a reaction to occur. I hope that you see here, examiner is checking. Do you know what activation energy is? Is that okay? We reduce, but when we reduce, it must not be below activation. For example, I remember that the production of ammonia is actually exothermic, all right? But to maximize the yield of ammonia, the optimum temperature is 350 degrees Celsius. That's the optimum. So an examiner would ask you, in order for us to increase the yield of ammonia, what should we do? We decrease what? Temperature. That's too vague, though. You decrease temperature. So you decrease, but it must not be below what? 350. Once you go to 340, these particles will not have enough kinetic energy for collision. When will a reaction take place? When particles collide.
So how can we know in an exothermic reaction if it's reversible or forward? If it's favored in the reversible or forward?
How do you mean? Your question is too...
So like if it's like how do you say a decrease in temperature favors exothermic?
Yeah?
We say therefore it favors the forward or reversible reaction.
No, which one is... Look at the... Okay.
How do we know whether it's forward or reversible?
No, check the temp... What do you have here? They gave you this. What does that mean? The forward is what? Exo. And the reverse is what? Endo. It's there. This one would be there. Or they tell you it is what? Negative. They'll give you an idea. So you'd know which one is exo, which one is endo. When they don't give you this, I'll tell you the question that's going to happen. That question would come after Kc. Kc is increased when temperature decreases. Is the forward reaction exothermic or endo? Here they won't ask you whether it's exo or endo. They've already told you it's exo. Right? And that's in its 4 marks. I'll explain that. Are we okay that it's cool, yeah? Fully explain your answer. I think we are done with the explanation. A decrease in temperature will favor the what? A exothermic what? Reaction. The reverse reaction is... the forward reaction is favored and more products are formed. Guys, whatever is favored increases. Are we okay, everybody? All right, let's quickly run through and answer. We're doing good. Oh, yeah. I love this, Casey. I love it with all my heart. This is the best Casey ever. There are 2 cases that I love. One from Gauteng 2019, where they gave number of particles. Yes. I think it's Gauteng 2019, I'm not sure, but they gave number of particles. It's very easy. I'll explain that when I get to the table now. Let's quickly look at this. The equation below represents the reversible reaction that takes place when NO2 is converted to what? N2O4. We have that. Is that fine? We all know that we use the table, right? That's the easiest way. There are other methods, but can we not talk about other methods? It's too late for that. Okay. So we just go for what? We go for the table. All right. So can we draw the table quickly, everybody? Oh, I think we answered this question already. Reversible reaction. A reaction where what? Products can be converted to reactants. Initially, X moles. Okay, let's draw the table together, everybody. Let's draw the table. Please, I need you to follow. This table, Zintle, this is for you. It's dedicated to you, my child. All right. Okay, guys, let's quickly work. What do we have? NO2 time, N2O4, 2:1 there. What is this? Ratio. What do you have? Initial number of moles. What do you have? Change. Please make sure you always work in moles, whatever they give you. All right. And what do you have here? Equilibrium, number of moles, and then concentration, which is number of moles divided by volume. Please note, here we work with what? Number of moles. How do you convert? If they give you mass, you say number of moles is mass over molar mass. If they give you number of particles, you say N over what? Na, where this one is what? your Avogadro's what? Constant. It's there on the formula page. Some of you have never used this before. I'll look for that question and I'll look for that question today and send it to you. Is that okay? Just for practice purpose. All right. They can also give you concentration from the beginning. Know that N equals to what? CV. Or C equals to N over V, right? Good. All right. We, we have one reactant and we have one product. Just for emphasis. Okay. Just for emphasis, one reactant and one product. Now, let's see. Initially, please take note of whatever they give you. X mole of what? NO2. You know, many a times we just read. And right now in your head, I know you say that is 0. Please, it's not always 0. Read. I have questions where it's not 0. Just I cannot look for them. It's too late. But how do I know this one will be 0? Initially, X moles of NO2 is sealed in a 1 dm cube. That's the only thing there. Is that okay? So it means at the beginning we have what? X, and this one is not there. By the way, my volume is what? 1. We okay? Lovely. Please, let's make sure you read. When equilibrium, please know that when we talk about that equilibrium, we are now here. Okay? When equilibrium is established at this temperature, 0,81 what? Underline those units. They are very important because sometimes they give you concentration. Of which compound? N2O4. Okay, so what do we have? Of? What do we have? 0, 0, moles, please. Because somebody's going to put it here. And that will be wrong. That is 0,81 moles per dm cube now. Please, I know we don't like reading. So what do you have? 0,81. Are we there? Now check. Look, products will always increase though. If you check this is starting from 0. We are ending at what? 0,8. Product will increase. Reactant will what? Decrease. Plus and minus. Are we okay? It's very easy. This is where learners now lose it and write whatever they want. I'm looking for those. Those are the two missing things that disturb learners. We normally call this a rice table, right? I always like to say, let's complete the food. Rice and chicken. Can't just give me rice. Where's the chicken? All right. Ratio and change. Make sense, everybody? So you work with ratio and all you are doing is you're going to cross multiply. There are different ways, but that's one way that I just feel I've tried it several times and it just makes sense. Now, what column has more information? 0 plus B. Simple maths. 0 plus B equals to 0,81. What is B? Thank you. 0 plus B. Don't use a calculator, please. 0,81. Now, what do? We cross multiply rice and chicken. Rice here, chicken there. Rice here, chicken. Does that make sense? So what do we have? You see, it's rice, chicken. You know, learners come here and do funny, I don't know what they do. But they just cross multiply, I don't get it. But it is rice and chicken. Rice and chicken. What is 8 times 1? Okay. All right. 8 times 1. A. 2 times 0,81. What do we have? 1,62. Thank you, Mary. You're such a darling. 1, what? 62. Can we do simple math now? X minus 1. There's no answer. X minus 1, what? 62. Is that fine? Guys, it's just simple. Just take it down the way it is. Now, what is concentration? Ratios. This one is double of this one. It's double. Yeah. All right. What do we say? Concentration is number of moles divided by volume. What's my number of moles? X minus 1,62. But what is my volume? Okay. Thank you. And this is what? 0,81. Okay. Now, what is the Kc expression here? Kc equals to concentration of what? N2O4 over what? NO2. But there must be a square there. You know where that 2 comes from, right? And please take note, if it was a solid, this one will be replaced with 1. Solid and liquids. So we need to go there. When you have a solid or a liquid, the equilibrium concentration is 1.
So like if your reactants were a solid, then you put it as 1.
Yes. You don't come and substitute whatever you are doing here. It will just be 1 there. All right. What's the answer here? N2O4? 0,81 over. And that's what they ask us to prove. 5 marks is done. Check the question. Prove that. Are we okay? This is where the juice of the question is. This is where they added makeup to this question. This part. Oh, there's a lot of there's foundation, there's eyelashes. Yeah, this is where the thing. This is where the thing is. The thing that makes the pot to work. This is where it is. Oh, we put foundation over the. Oh, foundation is the base. Oh, okay, all right. Whatever. The lipstick, the eyebrows, the what. Here. All right, please, let's listen to this. Let's do this together. So basically, if you were given a normal Kc, that's what you do. Is that okay? Make sure it's number of moles. Please practice as many questions as possible. If you have any issues, throw it. Let's walk through it together. It won't be like yesterday where I was just hectic. All right. Now, check this. Let's read. 0,79 moles of what is added to the equilibrium what? Mixture. You know what we have done? This is now real Le Chatelier's principle. When the system at equilibrium is disturbed, the equilibrium will do what? The system will reinstate a new what? Equilibrium by favoring. Okay, by favoring the reaction or by favoring what the reaction that opposes the disturbance. So it means when we state Le Chatelier's principle. All right, guys. Sorry, my mic was off. I was saying the examiner here is testing your knowledge of the principle, because many times we just state it. We actually know it to write that 2 marks, not to really apply. But now the examiner is testing. So it means when you state Le Chatelier's principles, there are 2 equilibrium states. You disturb the system when it's first at equilibrium. Then the system will what? Reinstate a new. So we're talking about how many equilibrium here? 2. First before disturbance, and then equilibrium after. Now check. Okay, let's add it. So this is our first what? Equilibrium. Do we agree? Now they said 0,79 moles of N2O4 is now added to the equilibrium mixture above. That's a disturbance. No, we don't work out concentration. It's moles. Don't mix it. Okay, just wait. Where is our equilibrium mixture? Here. Let me create 2 pages because I don't want to mess this page up. All right. So, can I take all of this out? Now, oops. So, this is our equilibrium mixture, number of moles. What are we doing? We are adding. It means we are disturbing. Once we disturb, we need to get another equilibrium. So we do the whole thing afresh. Is it making sense? Because we must evil sense. Are you aware that in this question, chemical liquid, the Kc is 11 marks? Maybe you didn't notice. That the Kc is 11 marks. You didn't notice? Check. Normally it would be 8 marks. But now it's what? 11. Okay. Are we okay? You get the gist now, right? Okay, now. So it means that, are we okay? All of these values are going to change. It means we have a new initial. Let's go back and quickly sort this out. Time. Ooh, I'm enjoying myself here. What do we have? It says what? 0.79 moles of what? N2O4. Please, it is what? Moles. It's now added to what? The what? Mixture. So we have disturbed the product. Hold on. Let's do something. If we disturb the product, what's my reaction? We increase this one. Where will equilibrium shift? To the left. Guys, we increase this one, right? We have caused a disturbance. What do we need to do? We need to use it. While we are using it, equilibrium will shift to the left. Which, yeah. Guys, you added more of this. There's an imbalance. This is now excess. You need to get rid of it. Look, I like chemical equilibrium. It's life. Okay. No. Bibi, it's very simple. It's very simple. Every time people get money, they increase their expenses because they must come to that balance of being broke. It's a balance. Right now, wait, see where you are. And on your way home, I just give you 500. You're like, what can I buy tomorrow? People hardly think of, oh, there's a 500, let me save. Yeah, it's hard. On your way, you're just going to say, from your car, you start smelling. You start smelling like, You check the queue. But it's not much, eh? Because it's a nature. I hope it makes sense. So, this thing increased. We need to balance it. How do we balance it? We use it. In order to use it, we are going to be favoring the reverse reaction. This one is going to what? Increase. Does that make sense to you? Equilibrium will shift to the left to favor the reverse what? Reaction. More reactants will be formed. Yes. Yes. So we help this one to come up because this one is cheating. The right side is cheating. We need to help the left guy so I can, at least we can balance. It's like your high heels. Sorry, I just had to go there. You are helping to balance by going higher to meet the boyfriend. Same height. I'm just saying. All right. High heels are equilibrium. They help you balance the height. Make sense? All right. Guys, are we okay with the balancing thing now? All right. Because you are short, you wear high heels. Lovely. Okay. All right. Let's finish. Now, what do we do? What was our equilibrium mixture of N2O4? 0.81. Now we add what? 0. Are you aware or are you okay with me saying that becomes the new initial? Because we are starting. No. It doesn't become a new, because now the system needs to do its own job. Yes.
Won't the N2O4 become a reactant?
No, it's still a product. But according to reversible reaction, it's a process where the product can be converted. It doesn't mean it has become a reactant.
But can't you like swap it around?
Don't swap it, please. No. Don't. Just follow the process. Yes? The new in it's not going. Okay, now it's asking the same question. Now, guys, please listen. Let's quickly go through. Let's follow the instruction and follow through. 0.79 moles of N2O4 is now what? Added to the equilibrium what? Mixture above. It is this compound. What was our equilibrium? 0.81. It has now changed. Remember, we are now disturbing. We need to give it some time. Is that okay? Give it some time to what? Get to a new equilibrium. So what is 0.81 plus 0.79? Lovely. That is what I now have. I don't know if it makes sense. Now, are you good? It was 0.81. We now added to what we already have. Remember I told you it will not always be zero. This is one of the questions now. Make sense? Fumani? 0.79. Is it 79? Yeah. Plus 0.81. Now, please talk to me. Oh, why it's not a change? Because, check this. Now, please check this now. Look at this. Are we okay, everybody there? When the new equilibrium is established at 350. Wait, please. Somebody once asked me, why do they always write this temperature? Good. The only factor that changes Kc is temperature. So here we are saying our Kc is not changing. All right. Good. It is found that, please watch this. It is found that the amount of NO2 increased. That's our change. And we answered that question already. Why? We said this guy will what? Increase. To favor the reverse what? Reaction. Does that make sense? It will increase by 1,2. So what do we have? Let's go. Where is that 1,2 coming? Plus. By the way, you remember we only did the change here. Did we touch this guy? No. The system will do its own job. So our initial here is x minus 1,62. Please, are we together? Increased by, and that we already answered by saying the reverse reaction is what? More products are formed. More reactants will be what? Formed. You see why it's still a reactant? It's not a product now. It's still a what? A reactant. More reactants are formed. That's the plus 1,2 there. Yeah, we created a change. The system is now, we created a change. Right? The system is now doing its job. By what? By what? Reinstating a new equilibrium. How will it reinstate a new equilibrium? By allowing the reactants to do what? To increase. That's what we explained here. We increased is now added. Then we leave it. It is the job of the system. Check, go back to the Chatelia's principle. When what's the principle again? When a system, the first word, when a system at equilibrium is disturbed. Hold on, let's ask ourselves, what disturbs the system? Human factors. And what are we changing? It's either we change concentration, or we change what? Temperature, or we change what? Pressure. We are the one doing the disturbance. So what have we done this time around? We have changed concentration by adding more moles. Are we there? No. You're confusing yourself a lot. Once we disturb, we cannot be at the same. I want you to take the words of Le Chatelier's principle and go through don't just define. When a system at equilibrium is disturbed, the system will reinstate what? A new equilibrium. So, this is the first equilibrium. We now created a disturbance. What will the system do? It will what? Create a new equilibrium by favoring the reaction that will what? Oppose the change. We increase this guy. The system will say, thank you for increasing. I know what to do. I will make sure this one increases. So we are now at a balance. Where is the increase? Plus 1,2. It's not the new equilibrium. It's what has been added. We added it so that we change the system, and the system will then create its new what? Equilibrium. We added it to this. No, it won't. He said it's now added. If 5 is added to 2, the 5 is not on its own. It's 7. No, I'm explaining. Now, can we finish this? That we don't know that, right? Can we cross multiply again? What are we rice and chicken ratio and change? What would this be? 2b. Okay. Can you give me a value? All right. So 2b equals to what? 1,2. What is b? 0,6. Thank you very much. All right. Now here's the thing, guys. Here's the thing. Remember, we had increased this guy. We had increased this guy. What will the system do? It will use it quickly. If it's using it, what's going to happen to the quantity? Lovely. It will decrease. I just wanted to tell you something here. It will decrease. Minus. We can now solve. We increased the other one, right? What will the system do to favor this side? It will use it to produce more of the other one. If it's using, what's happening to the quantity? It's decreasing. You cannot have both the product and the reactant at the same time. No. There's need to be equilibrium. So can we do the maths now? What is 1,6 minus 0,6? 1. What will this give you? Thank you, baby. Can we calculate concentration now? X minus 0,42 and 1. Makes sense? Remember we had a Kc expression. It is concentration of this over that. Can we redo that Kc expression now? Yes? It's a sealed container. Yeah, it didn't mean we changed the container. If you pour more petrol inside that container, what happens to the size of the container? It's a container. It's a 25 liters. Right? If I add more petrol, what is the size of the container? Thank you very much. The volume of? No, it is the volume of the container. It's not the volume of the container. That's why we go back. Let's check. All right. Biggie, check. Okay, check. Check, Biggie. In a 1 dm cube container. Remember, it's a gas. A gas will always fill up the space. So the gas automatically fills the 1 dm cube container. Makes sense? So we are looking at the volume of the container, not the content. All right. That's acid and base. When you pour more water into something. All right. Okay, so let's finish this. Let's finish. All right, what's our Kc? 1 over x minus 0,42 squared. Okay, guys, please let's finish now. It's now met. Kc. This is the new what? Equilibrium. Is that fine with us? So all the drama of what we did is now making sense, right? Kc equals to what? 1 over x minus 0,42. But remember, did we change temperature? No. Kc value will not change. It means Kc of the new equilibrium is the same thing as Kc of the what? Old equilibrium. Because only temperature affects Kc what? Value. 1 over x minus 0,42x is equal to 0,81. Oh, sorry. Squared. 0,81 over what? What was that? Huh? All right, 6 squared. Please, this is not math. Let's run through quickly. Let's run through the math. We don't expand, please. Don't start looking for quadratic. We don't have time for that. Is that okay? Please, under. Oh, you are expanding. Okay, math rule. This can come here and this can replace that. I hope you know that. Or let's cross multiply. Because I can see your face. I see your face like, okay, what are you talking about? Let's cross multiply. 0,81 multiplied by x minus 0,4. I'll tell you your possible mistake is to multiply there. There's a problem. Please don't do that. Yeah, we can actually find the square root immediately because we are multiplying. But can we divide both sides by this whole x thing? So what are we going to have? 0,81 equals to what? X minus 162. Is that fine? Over x minus 0. Are we okay with this maths? Now, it's squared there, right? We can simply say 0,81 equals to x minus that over x minus 0,42, all what? Squared. Can we then find the square root of both sides? What do we have? 0,9 equals to x. I'm not going to, this one you are going to do on your own, please. Cross multiply and solve for x. Yes, sir. About 2 marks. In fact, yeah, final answer is x. Yeah. But for equating, you'll have gotten 1 mark. And for this other method, they want answers now. Okay. Guys, can I run because of time now, please? Would make sure you can get the slide and finish the maths. Okay, let's quickly do this. 2 acid HX and HY of equal concentrations are compared. The pH of X is what? 2,7, and the pH of HY is 0,7. 7.1 is an acid in terms of Larry Bronsted. An acid is a proton donor. All right, lovely. Which acid X, HX, or HY is stronger? Give a reason. A lower pH. Because it's, guys, at 7, it's neutral. Then we start moving down. As we move down, it becomes what? Stronger, more acidic. All right. Which one? HY. Because it has a lower what? pH. Acid HX ionizes in water according to the following equation. The Ka value, this examiner, Ka value is 1,8. This one is a very good examiner, I'm telling you. Throwing punches in all questions. I think that's why the organic was quite flowing. All right. They knew that they were going to hammer you somewhere. All right. The Ka value for the reaction is 1,8 times 10 to the power negative 5 at 25 degrees Celsius. Do you understand what Ka value? That's what the examiner is saying. What is Ka? Constant what? Do we understand? You are telling me the meaning, the impact. Do you understand it? That's the thing. Okay. Tesmia, let's quickly look at weak acid together. Guys, I'm not going to define. I'm only going to express the definition in 4 different ways. What is a weak acid? An acid that ionizes what? Partially. To do what? To produce a low what? Concentration of hydronium what? Ions. Please look at this. I will help you with this and you can answer multiple choice. What does this mean? It means the concentration of the acid, I'm just going to use this one as the acid itself, is greater than the concentration of the hydronium what? Ions. That's what it means. The amount of hydronium ion produced tells if an acid is what? Weak or strong. If it produces a small amount out of the original acid itself, then we say it is a weak what? Acid. So here we are saying the concentration of the acid itself is more than the hydronium ion it produced. It's a weak acid because it produced what? A small what? Amount. This really tells you that the reverse reaction is favored. HA plus, Butle, your face. I'm showing you, it's fine. Alex, you know I always find a way to go to your kitchen to explain. H3O plus what? A minus. Do you know what's happening here? Which side is favored? The reverse. What does this mean? I want to help you now here. More. This is greater than that. That we go. Does that make sense? Wait. Number 4. Can we find Ka? Just the way we're finding Kc. Concentration of product over what? Reactant. What are we going to have? H3O plus. Is that fine? A what? Minus. Over what? Talk to me. HA. H2O. Ladies and gentlemen, that's a liquid. Constant equilibrium concentration of liquids would be what? 1. So can I just remove it? Because it's 1 there. Make sense? Check what we have. Look, this is very, very small. It's negligible. If we compare these two, if this number, which one did we say is big? HA, right? If this number is big, this value will be not just small, less than 1. Mathematically, when the denominator is bigger than the numerator, you're going to get 0, comma. What is 3 over 4? Once the denominator is bigger than the numerator, your answer is less than. Therefore, for a weak acid, Ka is less than 1. If I were to write for you, so if I'm an examiner, I will put 3 of this in multiple choice. Is more. Because we are not favoring the formation of hydronium ions because it produces a low. So we're not favoring the forward. We are favoring what? The reverse. I shouldn't be an examiner, eh? Okay. So what would you have for a strong acid? Everybody, let's work. Number 1, it's going to produce what? A high concentration of what? Hydronium what? Ions. Number 2, this now will be, okay, let's just use that. It will be greater. Still the same thing like you're saying, right? Is it making sense? Because all the acid have been ionized to produce a high concentration of hydronium what? Ions. Number 3, if we look at our reaction plus H2O, which reaction is favored? The forward reaction is favored. And what do we have? H3O plus what? A minus. Number 4, can I just conclude that Ka will be greater than 1? The same thing with Kc. If Kc is greater than 1, more products are formed. If Kc is less than 1, guys, can you please check? Let me show you something. Reactant, end product. If I say Ka is, or let's say Kc, even Ka, Kb, Kc, whichever one, greater than 1, check where your inequality is pointing to. It's pointing to the right. That side is favored. If my K, A, B, C is less than 1, it's telling you we are going, guys, we are moving to this side. I don't know if it makes sense. The arrow says, look left, go left. That's where we are going. That's where we are more. We are favoring the left-hand side. Does that make sense? Does that make sense, everybody? All right. I think we have answered this question. We've over-answered, but it's good. Okay.
Just announce it, right?
Okay, you've got 6 minutes left. Make sure your name.
Okay, guys, can we quickly answer? No, can we answer this question? Acid ionizes, we'll go back there. The value of Kc, check the Kc. It's 10 to the power what? -5. 0,000. So what is it? It's a very weak what? Acid. Now, if it's a weak acid, what do we know? The concentration of the hydronium ion is very what? Small. So, is the concentration of hydronium ion higher than, lower than, or equal to? It's lower than. Give a reason for your answer. Ka is less than 1. It is a weak what? Acid. Yeah. Okay. I'm moving quickly. Can I move? All right. Now, let's say this one. Beautiful question here. Let us add 150 cm cube of sodium hydroxide solution of unknown concentration to 200 cm cube of a 0,3. I've done this question before, but the question was forward. This one is going back. All right. If you want to see this, I did it last week. Did I? I think I did. All right. Anyway, they found didn't we do a question where we're finding the pH of the final solution? We did. But now they've done that for you. Please, let's quickly read. And the diagram says it all. What happened? They poured what? Sodium hydroxide into HCl. Are we okay, everybody? Is that fine? Do you notice the volume has increased? They even drew it for you. Now, what is the total volume here? 350 what? cm cube. We okay? Lovely. Final solution. And they told us pH is equal to what? 2. If the pH is equal to 2, what does that tell you? It is acidic. Make sense? Now, do you notice we have sodium hydroxide and HCl? If it was neutralized, pH would be 7. Strong acid and strong base. But now pH is equal to what? 2. It's acidic. It means that the acid is excess. Some of the acid was neutralized, but not all the acid was neutralized. Make sense? All right. Are we okay? Lovely. We have that reaction there. Calculate the concentration. Oh, we've done this over and over again. What do we do here? H3O plus is equal to 10 to the power of negative what? pH. You remember that, right? What's your answer? Quickly, give me an answer. 0,01 moles per dm what? Cube. Make sense? Get one for the formula, get one for the substitution, get one for your answer. Are we okay, everybody? 3 marks done. Now, initial concentration of, this is where the work is. So please follow so we get this done quickly. Electrochemistry can be done fast. Just 2 questions remaining. Am I right? Lovely. Which other question is remaining? We've done all the topics. All right. Can we now walk through this? Please listen. I want you to follow me. For us to have gotten this pH, it was the excess. Make sense? What was the original number of moles here? N equals to what? CV, which is what? 0,03 times 0. Guys, remember, we don't work in cm cube. The original number of moles is 0,006 moles. Make sense? We added N moles of sodium hydroxide, which we don't know. But already we know this one was what? Excess. So some of the base neutralized some of the acid. Not everything was neutralized. The excess is what we used here. Does that make sense? Now, concentration is number. Okay, wait, hold on. What are we looking for? Let me keep my rule. I want to keep my rule. What are we looking for? Initial concentration. Check this. What is N equals to, no, sorry. What's the formula for concentration? C equals to N over V. What were my rules of stoichiometry? They will not give you the number of moles of what you are looking for. You need to calculate the number of moles of the other substance that reacted. Use mole ratio to get the number of moles of what you want. Now, when you get the number of moles of what you want, you can solve whatever you want. Same thing, 3 steps. It's the magic rule. So we don't know this N. We need to find it. How do we find it? We need to find the N of the acid that what? Reacted. Please. Don't say, but we already have it. Mole ratio requires the number of moles of the other substance that reacted. Does that make sense? It is the one that reacts. All right. Let's go get the number of moles we now have. Since our focus is to get the number of moles that reacted. Do we have our concentration? 0, comma. What did we get? 0, 1. We don't know the number of moles, right? This is still the final what? Remember, this is the final solution. Remember, we started from pH, right? We went to concentration. Now we are looking for the number of moles. Do we know the volume? 0, comma. Is it 0.35 or 0.35? Test me. 350 divided by 1,000. Test. Please use a calculator. 0.35. Guys, are we okay? We are still focused on the final what? Solution. Can we cross multiply now? Number of moles. But of which compound determined this? It was the HCl, right? What is this? 0, all right, 0.035. Make sense? Okay, use your calculator. Anyway, moles. Are we okay? Now, please, this is the number of moles of HCl that was in what? This is what determined the pH of the final solution, by the way. Make sense? The pH is determined by what is excess. So the excess is in the final solution. From the pH, we got concentration. From the concentration, we got number of moles of what? Excess. Final solution had what? Excess hydrochloric what? Acid. Make sense? So we have the number of moles of the excess hydrochloric acid. By the way, we have the number of moles of original as well. Does that make sense? If this is excess, can we find the number of moles that reacted? It is number of moles of original minus number of moles in excess. Does that make sense to you? It is the original that we used, and then we have the remaining. Does that make sense to you? Original is equal to what we used and what was remaining. Okay, maybe if I write it this way, it will make sense. Let's say N original is equal to number of moles that reacted plus the number of moles that is in excess. Does that make sense to you? Now, what is the number of original moles? 0.006, I think. Do we know the number of moles that reacted? No. But do we know the number of moles in excess? 0.0035. Can we calculate the number of moles that reacted now? What's your answer? 0.0025 moles. Of what? So the number of moles that reacted is 0.0025 moles of what? Hydrochloric acid. This is the end we're looking for. Can we now do step 2? Mole ratio. HCl and what? Sodium hydroxide. It is 1 to 1. What do we have? 0.0025 would give me N. Can we cross multiply? N equals to what? 0.0025 moles. Are we together? Now I have my N. What am I looking for? Concentration is not, okay, let's be specific. Concentration of what? Sodium hydroxide equals to what? N over V. Do we know our concentration? That's what we are looking for. Do we know the number of moles? By the way, this one is number of moles of sodium hydroxide. 0.0025 What is the volume of my sodium hydroxide? 150, which is what? 0.15. Give me your answer here. 0.166, which is 0, what? 0.2, 2 decimal places, right? Moles per dm cube. We're done. Guys, it still follows the other way. The same way, step 1, step 2. So think through before you start calculating. Are we okay? All right, I'm going to send you the slides quickly once we're done. I hope we are okay. And then I'm uploading this immediately. Yeah? All right. Leslie, question quickly. Quickly. Leslie, your question quickly. Please get me get tables out. I don't want to switch in. Get your electrochemical tables out quickly. You need to find me answers here. Leslie, your question. I need to move to the next one. An electrochemical cell is set up, all right, using an aluminum rod and a gas. The EMF, guys, once I see EMF, okay, we're moving. Once I see EMF, what am I talking about? It's a galvanic cell. All right? Sir, then if we weren't told that it isn't neutralized or titration, okay, Leslie, I don't know. You still have not asked me a question yet. You can, look, Leslie, you cannot use Na over Nb equals to CAVA over CBVB except it is neutralized. That's the key. When it is complete neutralization, then you say Na over Nb equals to what? CAVA over CBVB. That formula is only meant for complete neutralization. When it's incomplete, you cannot. Because that formula is telling you Na, number of moles of the acid, is equal to number of moles of the base. It's a very, very tricky formula to use. Yeah. Leslie, I don't understand, but even the normal way doesn't give the same answer as the pH. Leslie, I'm not sure of what you're talking about. Maybe you should send me a picture of your solution, or you just talk to me because I'm confused with what I'm reading here. Which normal way are you talking about? Yes? Which formula? Okay, what will be your concentration? Or what will be your... Okay, guys, we'll make... Yes, C equals to N over V. Yep.
Yeah, but like, if we go in the full steps and like I use the mole ratio afterwards, it doesn't give me the same answer as when I'm using my pH to find the concentration. So does that mean that unless we talk unless we say it's titration or it's being neutralized, we don't stay away from the formulas?
No. When do you use mole ratio? Mole ratio is, you see, when we say mole ratio, it is always the number of moles that reacted. I don't know if that makes sense. Until you get the number of moles that reacted, you cannot use mole ratio. So you cannot use mole ratios from pH, no, because it's acidic. So we haven't gotten the number of moles that reacted. Every time we use mole ratio is used on the number of moles that reacted. Because you are saying, if 1 mole of this reacts with 1 mole of this, then that's what mole ratio means. 2 moles of this would react with 2 moles of that. So mole ratio deals with when you have found the number of moles of a substance that reacted. So don't use mole ratio except you have found the number of moles that reacted. I don't know if that makes it clearer.
No, we're not on the same wavelength. I know that, sir. It's like I'm doing the right thing, but it's not giving me the same answer. But it's fine.
No, if you say you are doing the right thing and you're only getting the same answer, something is wrong. You are doing the wrong thing.
But I'm not doing that.
What are you doing? What's your step? Quickly. You have 1 minute. Tell me your steps. What did you start with?
They gave us, okay, I think it's fine. I'll send you the question, or like I'll ask somebody.
Is this for this same question?
No, it's not, sir.
Okay, please, Leslie, I always tell you if you are talking about the question, can I see the question? Probably you are interpreting wrong, and we always have this fight every time. Send me the question so that we can all have the same point of reference of interpreting the question. I don't know whether you are interpreting wrongly. Good. I always say that. Don't interpret a question for me. Send me the question, let me interpret, and then we can argue on interpretations. Because if you are giving me a wrong interpretation, I'm only answering, my answer is definitely wrong. I don't know if it makes sense. Okay? Leslie, are you fine now? Please send me the question. It's easier. Then we have the same point of interpretation. Right. Okay, guys, quickly, let's answer. Yes, Mary, I need to run though. Please send your question. An electrochemical cell. Guys, do we all agree that this is galvanic? Let's see. Let's try this in 5 minutes and the other one in 5 minutes as well. Okay, what do we have? We have an aluminum rod and a gas. What are the conditions for this cell to operate? Standard concentration of 1 mole per dm cube, right? Standard temperature of 25 degrees Celsius, and standard what? Pressure of 1 atmosphere. Why are we using pressure? Because we have a gas. 3 marks in the back there. Okay. You use your formula page. If you go to your constant table, you find standard pressure there. Mary saying, if I forget, what should I do? Go to the formula page. The formula page would help you. Let me quickly run to that formula page to show you. Guys, I hope you have your tables. Please, I need answers from you. I'm going to be trusting your answers. So I need everyone so we can compare. Mary, that's your standard pressure there. Is that fine?
Yes, sir.
Good.
Yes, sir.
Don't come here and say standard temperature. No, you'll be lying. This is your standard temperature by acid and base. Do you see that? 298 Kelvin. Are we there? That's your standard what? Temperature. That's your standard what? Pressure. And obviously, standard concentration. Just know that one is 1 mole per dm cube. We're done. Use a calc. Yes?
Mine doesn't have a standard.
It's from China. Mary, that's all this Gauteng one. It's from China. The paper. That's why the paper had errors. All right. The final one would definitely have. Don't worry. The final one comes from my office, so it has. Okay. Guys, can we identify X quickly? Can we identify X? We are told that what? Initial is what? 2,98. But you see, they didn't tell us which one is the anode or the cathode, right? But I know. How do I know? I'll show you something quickly. I know which one is the anode. No. Let me show you, because we want to save time. I want to show you a little secret that I discovered here. Please, where is this? Where's my table? Oh, this formula, this one also is from, I don't know, Afghanistan. Doesn't have. Okay, this was June. That's why. If I go to a full, no, you see that one was just a prelim test. No, a province test. This is a final. No, why am I looking at memo now? Paper 2. Okay, supplementary. Now let's go to the table. Please, everybody look up here. I want to go to the table and do something very, oh no. This doesn't, okay. Can we just go to November 2022? Maybe we can get it. Wouldn't you like us to go to November 2022? Why not, if not? So you can be arrested. Karen is sharing, eh? Beautiful. Really? Huh? No. Biggie? We are not doing anything. Can I answer my question? Please check. This is 4B. This is 4B, right? Let me show you something. This is 4B. Where is million? There. Do you know there's no gas on top? There's no gas right here. They are all metals. So, if this is 4B, all of this is the anode. From anywhere going down is cathode. So, gas. Okay, so E cell equals to what? E what? Cathode minus E what? Guys, do we have the, let's run, 15 minutes. Do we have the E cell? What is the E cell? 2 point something. We don't have it, bruh. If you're telling me 2 point. 2,89. Come, let's work. 2,89. Already, guys, we know that whatever we are looking for is the cathode. So, otherwise, you'll be doing trial and error, and we don't want to waste time. What is AL? Negative 1,66. Do you want to give me an answer? 1, so, thank you. E cathode, therefore, is 1,23 volts. Positive. Is there 1,23 here? What is it? All right. They told us it's a gas. So it's what? Oxygen. It's here, 1,23. It's oxygen gas. It's a gas. 5 marks. 1, 2, 3, 4, 5. We're done. Identify using a calculation the gas. Make sense, everybody? Yeah, the gas. Identify gas X. They didn't say reaction. They want a gas. Done. Don't write the whole thing. Write the formula of the reducing agent. What do we know? The reducing agent is always what? Oxidized. Guys, I've taught you how to use a formula page. Do you remember? No, I don't want to read. Leave the oxys as red. Check here. Okay, I know Biggie, BB. Sorry, I called you Biggie. Biggie. Oh, lovely. All right. Check this. Let me cut this out. And, this. But guys, we tried, eh? We tried. With all the explanation, still working in 3 hours and few minutes. Yeah. Thank you very much. All right. Anyway, let's get this done, guys. We just read this down, right? Cathode, reduction, and oxidizing what? Agent. Anode, oxidation, and what? Reducing agent. What is the examiner asking you? Examiner asking, write the formula of the what? Reducing agent. You are looking for what is at the cathode. Does that make sense? We are looking for reducing agent. We are looking for what is at the, what is at the anode. Make sense? Okay. And we are looking for what is oxidized. Okay. Can we go back to our formula that we did? Anode. That's what we are looking for. Oxidation. What do we do for oxidation? Z. Make sense? Anode and cathode. The anode says start from the right, go to the left. Which one is the anode? That. So what's our answer? AL. So we're done there, right? Can I agree that we're done? Make sense, everybody? Al to what? Al3 plus 3, because we are looking for what is oxidized. 1 mark there. Oh, no, that's the equation. I actually answered. What is oxidized, guys? It's actually Al. They didn't ask us for the reaction. They said, name the formula of the reducing agent. They are looking for what is what? Oxidized. 1 mark. If they ask you for the equation, that will have been what? 2 marks. Write down the half reaction that takes place at the cathode. Do we know what's at the cathode? Oxygen, right? Good. What do? We copy and paste. Copycat. Copy the cathode. Can I pass? But that should be 1 arrow, not 2. I'm moving. Okay? Not here. Write down the cell notation of the cell. Cell notation is as simple as what? ABC. I want us to write this one. What do we have at the anode? It's Al, right? So what do we have? Al solid, Al3 plus, which is aqueous. So we have a salt bridge, right? Okay. What was our cathode? We start from O2. Is that okay? We go to 4H. So what do we have? O2 gas. We don't write the 4. H plus, which is what? Aqueous. Are you with me? Okay. No, relax, guys. We don't write the 4. 4 is just for balancing. We don't write the 4. What do we have at the end? H2O. Don't write the 2. H2O, which is what? Liquid. There's a problem. This thing must end with a solid. What solid do I have? Platinum. Now, do you notice all of these are in different phases? What do we do? Slash, slash, slash. Platinum. This is called a phase what? Change. If there were 2 phases, we use what? Comma. All right. Guys, are we okay? Now, which container, zinc or copper, will be more suitable? I always answer this, guys, if you remember. This is spontaneity. Let's quickly answer it again. Which container, zinc or copper, will be more suitable to store an aqueous solution of what? Nickel. Okay. Let me do this. Don't just jump. Don't just jump, please. We don't jump to answer this. You never said anything. Okay. Let's see. I don't think the electrolytic will take us time, right? This is where, okay, but we'll see. This is where more marks are. Guys, please, let's check. You know what we are going to do? In order for you to, please, I want to show you how to answer this question. Let's compare the two. Let's quickly compare what? The two. We are looking at zinc and what? Nickel. And we are also looking at what? Copper. And remember what they said? They said a zinc container. Or what? A copper what? Container. Automatically we know container must be what? Solid. Can we go check our table? Which one will be oxidized? Which one would be reduced? Mary, please just use platinum. Don't use lead. Don't use nothing. Platinum. Finish. Okay? I had a question here like, please, platinum. Don't change. And why do we use platinum? It's a solid, it can conduct, and it's inert. Okay, solid, it can conduct, and it's inert. It doesn't react. All right, guys, can we check which one would be oxidized and which one will be reduced? Please use your tables. Zinc and copper. Why are you going to zinc? We are comparing zinc and nickel. Child.
Yes, so zinc is oxidized. And nickel is reduced.
You said, everybody heard what you said. You said copper. And then she's trying to blame me now for. Okay. If we check zinc, where is zinc? Where did you find zinc? All right. Zinc and nickel, right? So zinc is the anode, and copper would nickel would be the cathode. So it means let's write the half reactions for you to understand. I want to show you how to approach this question. We said which one is oxidized. So what will your reaction be? Zinc into what? Zinc 2 plus 2E minus. Nickel would be nickel plus 2E to give us what? Nickel. Are we okay there? Is it 2 or 1? Let's see. Yeah, it's 2. Are we okay? Ni2 plus, remember it's the cathode. We just copy the cathode. But if I compare nickel and copper is here, right? It will be the opposite. Okay. And if you can see that, you are already done. Sorry. Ni2 plus. In this case, what are we going to have? Ni will be oxidized, right? To what? Ni2 plus 2E. And copper will be what? Cu2 plus 2E minus to give us what? Cu. Now, please let's check. We focus on the reactants. Now, what do we have? What's my reactant here? Remember they said nickel 2 plus ions. Do we have nickel 2 plus ions here? Yes. Is that fine? Do we have zinc solid here? Good. What is your zinc doing? Your zinc will be oxidized to what? Zinc 2 plus. This is a solid. This you cannot see is an ion. It's invisible. It means your zinc will change to zinc 2 plus. This thing would have holes. The container is being eaten up, converted into something you cannot see. So it's not safe. It's exothermic. It's spontaneous. This reaction is what? Spontaneous. Why? It happened. So if you put nickel compound into the zinc container, this is the reaction that will take place. By the time you come back, you'll find your container gone. It has been eaten up. By what? By the nickel. The examiner says refer to what? Relative strength of. Please, you refer to what? Reducing agent. Now, which one is a stronger reducing agent? Let's compare. Remember, a stronger reducing agent is easily what? Oxidized. Are we okay? Zincle, are you fine? All right. So, can we say zinc is a stronger what? Reducing agent than what? Not nickel. It's nickel what? 2 plus ions. Okay? Therefore, zinc will be oxidized to what? Zinc 2 plus. Creating what? Holes in the container. Guys, once you see ions are invisible. They said, which one is suitable to store? So, not what? Suitable. Does that make sense? So, which one is suitable? Copper. So, just come here and say, copper is what? Does that make sense, guys? This is how we do spontaneous what? Reactions. Somebody else can answer by copper by saying, copper now is a what? Or you can say zinc is nickel is a stronger reducing agent than what? Copper. So copper will not be oxidized. Does that make sense? Let me add that here before you take your picture. Nickel 2 plus is a stronger reducing agent than what? Copper. Copper will not be oxidized. Does that make sense? All right. 1 minute. Do you think we can? The last one. Was it, you guys, did you try it? Are we okay here? What is this? Electrolytic. Check. 1, 1, 1, 1, 1. The simplified diagram represents what? An electrochemical what? Cell. I'm going to be fast here. Electrolysis of what? They said concentrated sodium chloride what? Solution. X and Y are carbon. Define electrolysis. The chemical where what? Electrical energy is converted to chemical. Chlorine gas is released at X. Please quickly look at where does chlorine gas come from? It comes from Cl minus. That's always know that. And the negative must be attracted to the positive. It means X is positive. Makes sense. Let's make sense out of it. And the anode is positive in the electrolytic cell. So that is my anode, and this is my. Look, if you can get that, the rest is history. Yeah? Letter X or Y. Okay, and what happens at the anode? Oxidation. What happens at the cathode? Do you know we are done with this one? Letter X or Y. Write down letter X, where oxidation takes place. It's X. Half reaction that takes place at electrode Y. All right? Half reaction that takes place at Y. Guys, they told us it's a what? So there's water. So what do? At Y, water is reduced. 2H2O to give us what? OH. No. There's plus there. Plus what? 2E to give us what? OH minus plus hydrogen gas. It's there. Okay? In which directions will electrons flow? Electrons will always move from the anode to the cathode. Which one is the anode? We're done. Balanced equation of the overall. This is at the cathode, right? What's at the anode? Cl, 2Cl minus to give us what? Cl2 gas plus what? 2E. Are my electrons balanced? Yes. So what do? 2Cl minus plus 2H2O to give us what? Cl2 plus OH minus plus what? H2. How many marks? 3 marks. Will the pH of the electrolyte change during this? Will the pH of the electrolyte change during this reaction? How will the pH change, right? It will increase. No. We are forming a base. A base is to the far end of the 14. Which two? Oh, 2, thank you. 2OH, right? So this one here is going to connect with the sodium that is there to form what? NaOH, which is a base. Make sense? I've already answered my answer. Give a reason for your answer. No, don't make it reversible. It's just one arrow. Ladies and gentlemen, this is it. Go get your A's in your paper tomorrow. Look, we covered a whole lot of concept today, and it was just beautiful. The whole paper. All right, except multiple choice, though. We didn't do multiple choice. But I think if you listen to all of the little notes I mentioned, it will have helped us with the multiple choice. Good luck, everybody. Get home, rest, rewatch, because I'm going to upload just immediately, and also send you the PDF. Okay. Okay, guys, goodbye on the online. Okay. All right. I'll send the link and then you can watch it again. Good luck. Good luck, guys. We'll talk party. We'll have a video call to do a party. We'll have a video conference. We'll do